चलिए, वेलकम ऑल। है सब लोग? आ गए सब लोग? शैल वी स्टार्ट? अरे रैपिडो बोलता है ये। वॉल्यूम बिल्यूम सब क्लियर है? वॉइस फीस बोलो। एक सेकंड प्लीज, आई एम जस्ट चेकिंग। अभी स्टार्ट कर लेते हैं। यस, लेट्स स्टार्ट। इफ देयर इज एनी डिफिकल्टी, अगर कोई डिफिकल्टी है तो तनुज विल कॉल मी। लेट मी फोकस ऑन द क्लास फर्स्ट। लेट मी फोकस ऑन द क्लास। So my dear students, I have tried my level best to include all varieties of questions. All varieties of questions. Just let us have a glance. What type of questions we have taken? These are all XC level questions. These are all XC level questions. Just observe here. एक बार देखेंगे क्या क्या questions हम करने जा रहे हैं. What are the various types of questions? And these are new questions. These are absolutely new questions. These are new questions, and we'll try thermodynamic relations, properties of pure substances, exergy. Then we have second law, entropy, and you also have applications in XE. Okay, these are all questions. That is steady flow, unsteady flow. Okay, then psychrometry. All these are there. ये unsteady का है. So I have tried my level best to include various varieties of questions, and there are 31 questions. I don't know how many questions we are going to do. It all depends on your patience and my patience. So straight away, let us get into the question. Please read the question. So if there is any difficulty, please do let me know, sirs. अगर कोई difficulty है तो मुझे बता देना. Dear students, if there is any difficulty, please do let me know. Okay, चलो. Tanuj will call me if there is any difficulty. है ना, sirs? Okay. चलो. Let's take the first question. और एक बात है सर, I'll be going a bit fast because I don't want to waste your time. So I'll be going a bit faster because all calculations I have done. So I will not waste your time in class. चलो, let's take the first question. The rate of heat transfer between certain electric motor, there is an electric motor, and its surrounding varies as he has given the rate of heat transfer. The electrical current is passed through this so that this motor is losing some heat. And that is given as Q dot. यहाँ पे dot है देखो, has given rate. So it is given as minus 0.2 into 1 minus e power minus 0. See, एक बात है सर, I tried to include all varieties. I tried my level best to include all varieties. ठीक है, सारे concepts एक बार brush up हो जाए. चलो, it is given as 0.05 t. ठीक है सर, question को देखकर डरो मत. And this is the heat transfer from the motor, where t is the time in second and q dot is in kilowatt. This is in kilowatt. ठीक है. The shaft of the motor rotates at a constant speed of 100 radian per second. The shaft is rotating, and you know, my dear students, it is taking electrical current. So work is done on the system, and it is developing some work. So there is a shaft work. So if you see the motor, there are two types of work interactions. One is electrical work input, that is on the system, which is minus, and the other is the shaft is developing some work, that is shaft work. The motor is developing some work, that is shaft work, and he has given the torque as 80 Newton meter, and the omega value is the shaft is rotating at 100 radian per second. Okay, the motor draws current from electrical plant, which is equal to 2 kilowatt. ठीक है sir. And which of the following graphs are correct? बोल रहा है. Two graphs are given. It is MSQ question. One is given for work which is in kilowatt. The other is given for change in energy in the motor. चलो कोई बात नहीं sir. Let me do this question sir. Very simple. I want work. How many works are there? There are two works. One is electrical work input. Other is the shaft work. So एक बार देखो sir. Now, what is the electrical work? And that work is given as 2 kilowatt. एक बार देखेंगे. That is given as how much is that? It is given as 2 kilowatt. So now you tell me, is it plus or minus? The work is done on the system, therefore it will be minus. So this is 2 kilowatt. This is electric work. And what is the shaft work? You know, the shaft work is given by power. Of course, it is rated form. It is rated form. It is torque into omega. The torque is given as, my dear students, the torque is given as 18 and omega is given as 100. So therefore, it is Newton meter radian per second, Newton meter per second. It is, the Newton meter is joule per second is watt. This will be in watt. And this is positive. So if you want in kilowatt, how much is this, sir? How much is this? I think if we divide with 1000, it will be 1.8 kilowatt. Okay. So what will be the total work for this motor? So work is done on the system, that is electrical work is -2. Okay, sir. Plus, देखो total work, there is shaft work. What is the shaft work? अरे यार motor is absorbing this much and giving some output. So total work is given by this as 1.2. Now you tell me what is the total work? I think it is 0.2 kilowatt. Is it a function of temperature? My dear students, is it? मैं थोड़ा चार्ट भी देखना पड़ता है एक बार. चलो कोई बात नहीं. I'll say, is it a function of temperature, my dear students? आप बताइए sir. Is it a function of temperature? No. So therefore, it is constant. It is not varying with temperature. So if you want the work input, इधर देखो. अगर आपको work input चाहिए, अगर दिख रहा है ना, सब कुछ दिख रहा है ना सर? So अगर वर्क चाहिए, it will be constant. टाइम यहाँ पे है, and this value is -0.2. This -0.2. एक बार ऑप्शन चाहिए. देखो, it is given as +0.2 and it is given as -0.2. So which one is correct? ये वाला correct है. Option D is correct. Option D is correct. Is it clear, my dear students? Option D is correct. बोलो sirs. Option D is correct. Yes. And he's also asking the change in energy. He's also asking change in energy. Of course, here kinetic potential energy changes are not given. So change in energy is nothing but internal energy. Okay. Now, my dear students, you know that d dash q is equal to du plus d dash w. Okay, sir. Let me write a bit thicker. Okay. Now, let me write this in rated form. तो आप rated form में लिखो. Rated form में लिखो. So I'll write this as d dash q is equal to, what do you mean by du? अरे d dash q का मतलब है d dash q by dt. So this is du by dt plus d dash w. Okay, fine, no problem at all. ये हो गया sir, my dear students, ये हो गया. अब देखो, already q is given, my dear students. एक बार देखना, how much q is given? Somewhere q is given. Where is that? Q is given as -0.2 into, यहाँ पे directly write down. Q is given as -0.2 into 1 minus e power -0.05 t. ठीक है sir, is equal to du by dt, and already you know the work. It should be net work. I'm applying for motor as a closed system. I'm applying for motor. So how much is the net work? -0.2. So this is -0.2. All are in kilowatt. Wonderful sense. Please tell me d dash q. This is q by t. Q by u du by dt. This is also in rated form. So you get this equation. So already q is given. Du by dt. W should be net work. Net, because it is taking something, giving something. So it is always net work. So हो गया sir. So -0.2. Minus of minus is plus e power. I'm sorry. ये इसको थोड़ा हटा देंगे. हाँ. ये -0.2. Minus of minus plus 0.2 e power -0.05 t plus is equal to du by dt plus -0.2. Very good, sir. -0.2 is gone. So you get du by dt is equal to क्या है sir? 0.2 e power -0.05 t. But he is asking the energy in kilojoule. एक बार देखना sir. If you see, this work is given in kilowatt, this is given in kilojoule. Let me try to solve this. देखो एक बार. तो du is equal to, इसको dt इधर ले लेना, 0.2 into e power -0.05 t into dt. Excellent, sirs. Now you integrate this. So if I integrate this, my dear students, from 0 to t, so what do you get? This way I get it as change in internal energy. Whenever kinetic potential energy changes are neglected, it is not given in the problem. So change in energy is change in, bolo sirs, change in energy is, bolo re, change in internal energy itself. So therefore, this will be 0.2 को बाहर ले लेना. What is e power -x? E power -x only, 0.05 by, समझ गए ना 0.05 ऑफ कोर्स ये माइनस आ गया यहाँ पे एग्जैक्टली so you will get the change in internal energy as कितना आ रहा है सर I think this you are getting 0 to t ठीक है सर I think you are getting this as 2.2 by 0.05 is I think it is 4 into e power minus 0.05 minus 1 excellent sir कहीं पे कुछ मिस्टेक हुआ सर ये माइनस है सर यहाँ पे देखो ये पे माइनस है तो इट विल बी माइनस यहाँ पे देखो e पावर माइनस 0.0 बाई माइनस 0.5 आएगा ये माइनस है माइनस तो डेल्टा u इज इक्वल टू इसको माइनस को अंदर ले लेना सो 4 into 1 माइनस यहाँ पे t है सर t इज मिसिंग यहाँ पे t तो 1 माइनस ये माइनस अंदर ले लेना तो 1 माइनस क्या होगा e power minus 0.05 t excellent sir this is the equation till now is there any difficulty sir till now is there any difficulty sir Mayank you are wrong because upper limit and lower limit the lower limit is upper limit is t lower limit is 0 e power 0 is 1 e power 0 is 1 but already there is minus यहाँ पे minus है sir because e power minus x is minus e power x तो minus नीचे आया तो ये आ गया sir excellent sir अब बोलो graph now you tell me what is the graph my dear students आप बताइए what is the graph excellent sir इधर देखो when t is 0 ध्यान से सुनो when t is 0 e power 0 is 1 1 minus 1 is 0 तो 4 into 0 is 0 delta u is 0 when t is 0 इधर देखो सर इधर देखो delta u is 0 देखो when t is 0 look at when t is 0 delta u is 0 means it is starting from origin delta u is 0 t is 0 it is starting from origin अब देखो I got delta u as एक बार देखना we got delta u as 4 into 1 minus e power minus 0.5 t सुनो carefully जब t का वैल्यू बढ़ रहा है ध्यान से सुनो can I write this as 4 into 1 minus 1 by e power 0.05 t लिख सकता हूं सर yes अगर जब ये नीचे आ रहा है जब t बढ़ रहा है दिख रहा है सर आपको can you see this yes so when t is increasing जब t बढ़ रहा है तो this denominator is increasing so this value is decreasing negative decrease मतलब ये delta u is increasing exponentially देखो ये बढ़ते जा रहा है तो but this graph says when t is 0 delta u is 4 ये बोल रहा है when t is 0 delta u is 0 no I got this equation when t is 0 e power 0 is 1 1 minus 1 is 0 4 into 0 is 0 delta u is 0 when t is 0 so delta u is 0 when t is 0 so this is the graph so a and d are correct is the first question clear sirs is the first question clear my dear students I am waiting for your answers is the first question clear my dear students is the first question clear बोलो सर कुछ तो बोलो you are not saying anything shall I proceed Arindam चलो let's go to next question without wasting time let us go to the next question very good sirs got it ना crystal clear thank you ये वाला लीजिए बहुत बढ़िया आराम से जाएंगे सर let's not run ये वाला लीजिए please read the question 2 kilograms of air initially at 5 bar 350 Kelvin. There is air. What is the mass of air? 2 kilogram. The pressure of air is given and the temperature of air is given. It is in the right side of the chamber. ठीक है sir. Now एक सेकंड रुको. यहाँ पे एक partition है. चलो there is a partition. On the left side there is carbon dioxide. I repeat. On the left side there is carbon dioxide, on the right side there is air. The carbon dioxide mass, the carbon dioxide pressure, the carbon dioxide temperature, air mass, air pressure, air temperature is given and this container is insulated and please note on that this complete container is the rigid one. Okay, ये पूरा rigid container है, ठीक है sir. Now, what he says? हाँ, contained by partition shows. The partition is free to move and हाँ this partition is free to slide along the length of this container. Very good sirs. Now ध्यान से सुनो. There is one word that is important. The partition allows conduction from one gas to other gas. Means if this is at 450 and I am sure that from higher temperature to temperature this partition is allowing heat transfer by conduction. But this is completely insulated. ये पूरा insulation है sir. Container is insulated. Please understand that This is subsystem 1, subsystem 2. Carbon dioxide air, ये भी मेरा system A है. From this complete system there is no heat transfer, but internally there is a heat transfer. ठीक है सर, लेकिन I am taking this whole as the system. This whole as the system. If I take this whole as the system, this is the boundary. So from the boundary there is no heat transfer. For heat transfer, it should cross the boundary. So you may be wondering, sir, अंदर हो रहा है ना sir? It is internal. So I have taken this as the system, this as the system, this is the total system. चलो, पूछ रखा है. Now, common sense. Equilibrium temperature, equilibrium pressure. My question to you people is, what should be the equilibrium temperature? Definitely, when there is a heat transfer, when both reach equilibrium, the final temperature of both should be same. Point number 1. I repeat, sirs, he is using the word equilibrium. When both are in equilibrium, the final temperatures of both should be same. Point number 1. Second point. And partition is moving, and finally, when the equilibrium is reached, this side pressure should be same. If this side pressure is more, it will push. If this side pressure is more, it will push. So there will not be any equilibrium. So if equilibrium is to be achieved, तो common sense बोलता है, इस side का pressure same होना चाहिए. Then only it will be equilibrium. Similarly, equilibrium temperature final. So can I say that finally, once the equilibrium is reached, both attain same pressure. When the equilibrium is reached, both attain same temperature. Because it is conducting. When it is conducting, there is a heat transfer. Both will achieve same temperature. Very good. That is equilibrium temperature. Similarly, both pressure should be same. This side. Why? Otherwise, equilibrium cannot be reached. Because if this pressure is more, it will push. If this pressure is more, it will push. Equilibrium के लिए finally both side temperature should be same. Please बताइए, are we clear, my dear? ये concept is very important. अभी तक हमने देखा partition is non-conducting, but this time we are seeing partition also conducting. Common sense. और एक बात है सर, you know R gas constant is R bar by molecular weight. Carbon dioxide के लिए it will be 28, and air के लिए I know it is R for air is R bar by molecular weight of air is 29, so it is 0.287. R bar is 8.314. ये पता है सर, मुझे बताइए. Can I calculate the volume of this? PV is equal to MRT. So we can apply ideal gas equation. Carbon dioxide के लिए इधर देखो. For carbon dioxide, PV is MRT. Mass is known. Some students may be wondering, sir, carbon dioxide के लिए R पता नहीं. What is the molecular weight of carbon dioxide? 28. So R is known. What is R for carbon dioxide? It is 8.314 by 28. I know R of carbon dioxide. Temperature should be strictly in Kelvin. Temperature is known. मैं सिर्फ carbon dioxide के लिए apply कर रहा हूँ. Mass is known, yes, and pressure is known. Pressure should be in kilopascal. Whenever R is in kilojoule per kg Kelvin, pressure should be in kilopascal. So I can calculate volume. So what will be the volume, my dear students? MRT by P. I'm calculating the volume of carbon dioxide. So therefore, volume is equal to mass of carbon dioxide is 4. What is R of carbon dioxide? 8.314 by 28 R. And why? Because R of carbon dioxide is 8.314 by 28. And what is the temperature? It is 450 by pressure. Please note down that whenever R is in kilojoule per kg Kelvin, pressure should be in kilopascal. 2 bar means 200 kilopascal. I can calculate volume. So directly I am writing, sir, the carbon dioxide volume of carbon dioxide initially is, when I calculate, I am writing directly, sir. It is 2.67 meter cube. Any problem, sir? Directly I am writing. सर ये कार्बन मोनोऑक्साइड है सर, इट्स नॉट कार्बन डाइऑक्साइड, ये मोनोऑक्साइड दिया सर. अगर कार्बन डाइऑक्साइड देता है, had it been carbon dioxide, it would have been 44 sir. Carbon is 12, the atomic mass of oxygen is 16, 12 plus 16 is 28. Clearly it is given as carbon monoxide. लिखा भी है सर पहले, थोड़ा क्वेश्चन को ढंग से पढ़ो, कोई बात नहीं. So similarly, I'll calculate the volume of air. What is the volume of air? Again I use the same equation, MRT by P. M is known, R of air is 0.287, T is known by P. P should be 500 kilopascal. So if I calculate, I'll also get volume of air. Anyone? What is the volume of air? Air or R? थोड़ा calculator ready रख लेना सर. All of you keep your calculators ready. This is the volume. Please बताइए, are we clear? My dear students, is it clear? क्या रे? कुछ तो बोलो रे. बोलो, टाइम वेस्ट मत करो रे. Clear? Chalo. Now I'll calculate the total volume of the container. What is the total volume of the container? Volume of carbon monoxide plus volume of air. You add both. If I add both, I'm getting it as 3.0718 meter cube. ठीक है sir. 3.01. Okay. Now what to do? What is the next step? I'll tell you. What should be the next step? I'll tell you. Listen carefully. Finally, are these volumes changing? Yes, sir. Because the partition is moving, final volume is changing. Listen carefully. Let V be the final volume of carbon dioxide. So I'll write here. Let V be the final volume of carbon dioxide. Carbon monoxide, sorry. What will be the volume of air? Anyone? My dear students, internally the volume is changing, but the total volume is constant. If this carbon monoxide occupies V, what will be the volume of air? The total volume is 3 point something. If this is occupying V, the air will be 3 point something minus V. So therefore, the volume of air is 3.0718 minus V. This is the volume of air. Is it clear, my dear students? आप बताइए sir. If this is clear, I proceed. Is it clear? Please बताइए. Are we clear? Yes. देखो, some students say, sir, heat transfer को equate करेंगे तो same होगा. लेकिन ये एक बार सवाल देखो सर. एक बार सवाल देखो सर. It is MSQ. Equilibrium temperature, equilibrium pressure, volume. देखो sir, don't think that I am a fool doing this. ये MSQ है. एक एक क्वेश्चन में सारे कंप्लीट करेंगे. समझ में आ रहा है सर? समझ में आ रहा है सर? राहुल बाबू, राहुल बाबा, have you understood? बाबा राहुल, बाबा राहुल. Yes. अब देखो सर. Wonderful sir. Wonderful. कोई दिक्कत नहीं सर. Now, please listen carefully. अब ध्यान से सुनो. मैं क्या कर रहा हूं? PV is equal to MRT. Let us go for final conditions. What is the final pressure? MRT by V. Very good. My dear students, can I equate the final pressure of carbon monoxide is equal to final pressure of air, because finally it is reaching equilibrium. So I will write this as MRT by V. This is the final pressure of carbon monoxide should be equal to MRT by V. It is the final pressure of air. But finally it is reaching equilibrium. So both should be same. Now, understand carefully. Don't cancel this R, this R. This R is for carbon monoxide, this R is for air. Don't cancel this volume. This is the final volume of carbon dioxide, this is the final volume of air. Mass. देखो एक बार. What is the mass given? Carbon monoxide 4 or air is 2. Carbon monoxide 4. What is R? R bar by 28. Very good, sirs. What is the volume of carbon dioxide? Finally बात करें equilibrium में. What is the volume of carbon monoxide? V. Excellent. V is the volume of carbon dioxide. R into T. देखो और एक बात. T is TF. Anyone in the class? This is the equation I am applying for final equilibrium pressure. So if it is the final equilibrium pressure for both should be same. So what will happen to this? It will be final temperature. Similarly, इधर आइए. M, I think it is 2. R bar by air के लिए 29. And what is the final volume of air? The final volume of air is 3.0718 minus V into temperature. My dear students, finally both are reaching equilibrium temperature. So final temperature will be same. तो ये कट जाएगा. ये R bar कट जाएगा. So everything is in terms of V. I will get V. Please tell me, is this equation clear? My dear students, क्या ये equation समझ में आया? किसी को तो समझ में आया सर? Please tell me, is it clear? अरे यार कुछ नहीं बोल रहे रे आप. कुछ नहीं बोल रहे. So if this is clear, I will proceed. If this is clear, I will proceed. अरे रे 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 रे. अरे रे 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 रे. क्या हो रहा है सर मेरे बच्चों को? हे कृष्णा, हे हरिनाथ, हे जगन्नाथ, ये क्या हो रहा है? कोई कमेंट ही नहीं आ रहा बच्चों का. I am not seeing your comments. Is it clear? कोई दिक्कत है रे? अरे यार, No comments from your side. I'm unable to see your comments. बोलो, कुछ तो बोलो. क्लियर, बहुत बढ़िया. So I will get V. सब कैलकुलेटर्स रेडी रखो. सब वंडरफुल. Someone gave it is 2.0716 meter cube. Can you tell me what is this? It is the final volume of CO2. Sorry, CO. And what is the final volume of air? Anyone? So final volume of air is 3.071 minus 2.071. तो ये आ रहा है 1 मीटर क्यूब. ये सर नो सर, एक बार ऑप्शंस देखना सर. एक बार हे कृष्णा जगन्नाथा. After equilibrium, the volume occupied by air is 1 meter cube. This is correct. After equilibrium, the volume occupied by carbon dioxide 2.07. This is also correct. Oh my God! I have to find out equilibrium pressure and equilibrium temperature. अब कैसे करेंगे बोलो रे? अब कैसे करेंगे? Anyone? देखो, PV is equal to MRT. ठीक है. तो देखो, simply the partition is sliding. There is no mixing between gases. So therefore, I will write my dear students, T is equal to, ध्यान से सुनो, V आ गया. क्या करेंगे सर? यहाँ पे T आने के लिए थोड़ा मुश्किल है सर. और कैसे करेंगे सर? Can you tell me? मुश्किल है सर. Final pressure is not known, final temperature is not known, so I am not in a position to apply P is equal to MRT for final state. कुछ बताओ? Yes, conservation of energy. First law of thermodynamics for a closed system. D dash Q is equal to du plus d dash w. Excellent sir. Look at carefully. ध्यान से सुनो सर. ये मेरा पूरा सिस्टम है. अगर ये मेरा पूरा सिस्टम, ध्यान से सुनो, अगर ये मेरा पूरा सिस्टम है, तो व्हाट इज द हीट ट्रांसफर? इंटरनली हो रहा है, इस बाउंड्री को क्रॉस नहीं हो रहा है. एंड मोरओवर इस कंटेनर इज अ रिजिड कंटेनर, सो पूरा अंदर ही हो रहा है. फॉर हीट एंड वर्क ट्रांसफर इट शुड क्रॉस द बाउंड्री. दे आर बाउंड्री फिनोमेना. कैन एनीवन कमेंट व्हाट इज द हीट ट्रांसफर एंड वर्क ट्रांसफर? एनीवन इन द क्लास? व्हाट इज द हीट ट्रांसफर एंड वर्क ट्रांसफर? ध्यान से सुनो. इट इज इंसुलेटेड. अरे यार, कंप्लीट कंटेनर के बाउंड्री से क्रॉस नहीं हो रहा है, so therefore it is 0 is equal to du, and it is a rigid container and there is no work, so internal energy is conserved. Excellent. What does it mean? लेकिन यहाँ पे internal energy is an extensive property. Whenever you want total extensive property, you have to add the total internal energy is 0. इसका मतलब change is 0. इसका मतलब internal energy change for carbon monoxide plus internal energy change for air, this total should be 0. Excellent. देखो, mCv dt, this is for carbon monoxide, plus mCv dt, this is for air, should be equal to 0. Excellent. What is the mass of carbon? देखो यहाँ से और एक बात है, लास्ट में कुछ दिया सर. देखो, take the ratio of specific heats as 1.395. मतलब 1.395 दिया. Gamma for both, देखो, for both air and carbon monoxide के लिए 1.395 दिया. कोई प्रॉब्लम नहीं है सर. इधर देखो, what is the mass of carbon monoxide? 4 दिया है. What is CV? Anyone in the class, what is CV? CV is equal to R by gamma minus 1. Excellent sir. या समझ में आ रहा है सर? So अगर आपको CV चाहिए, ध्यान से सुनो सर. CV is equal to R by gamma minus 1. Look at it. But what is R? इधर देखो सर. CV is equal to R को R bar by molecular weight gamma minus 1. कुछ कैंसिल होगा सर. M. What is CV? R by gamma minus 1. But what is R? R can be written as R bar by molecular weight. देखो, CV is R by molecular weight. देखो, R is R bar by molecular weight. R by gamma minus 1. ये किसके लिए है सर? कार्बन मोनोऑक्साइड. What is delta T? Final temperature minus initial temperature. What is the initial temperature of carbon monoxide? It is 450. 450. Excellent. Plus, what is the mass of air? 2. What is CV of air? इसी टर्म में लिखेंगे, कैंसिल हो जाएगा. R by gamma minus 1. R is R bar by molecular weight of air. R by gamma minus 1. I repeat, says CV is R by R is this R bar by molecular weight of gamma minus 1. What is the changing temperature? Final minus. What is the initial temperature of air, sir? 350. It is 350. चलो, this should be equal to 0. कितना इंटेलिजेंटली मैं क्या किया पता है? ये R bar, ये R bar, gamma minus 1 gamma. Why? He said for both gamma is 1.395. तो सेम है. तो 4 into what is the molecular weight of carbon monoxide? 28. Final temperature minus 450. plus 2 by, what is the molecular of weight of air? 29, and the final minus 350. अगर आप ये calculate कर रहे हैं, everything is known except TF. If you are calculating, you will get the value of TF. Anyone? मयंक क्या बोला? हाँ, बिल्कुल. Anyone? मुझे बताइए सर, आप लोग इन्वॉल्व नहीं हो रहे सर. Anyone? What is the value of TF? Sir, I am waiting, sir. When I calculate, I'll get TF as 418. Please आप लोग कैलकुलेट करो सर. इसमें सब है except TF. और wonderful राहुल बाबू को जिंदाबाद. राहुल बाबू 418 is correct. Excellent. इधर देखो, इधर आइए. The equilibrium temperature is 417.67, roughly 418. तो बिल्कुल ये भी सही है. Oh my God! I want the final pressure. देखो, I want the final pressure. How do I calculate final pressure? इधर देखो. PV is equal to mRT. You can apply this final condition for air or for carbon monoxide. No one will stop you. So if you want the final pressure, mRT by V. चलो एयर के लिए अप्लाई करेंगे, whether it is air or carbon monoxide, it will be same because finally it is reaching equilibrium. तो mass of air is this. What is R of air? 0.287. Excellent sir. What is the final temperature? 418. Final temperature. What is the final volume of air? I think it is 1. Final volume air के लिए अप्लाई. अरे यार, you can also apply. अरे आपको डाउट है तो इधर आइए सर. Let me apply for air. ये किसके लिए अप्लाई किए? Air के लिए. Let us apply for carbon monoxide. P is equal to mRT by V. चलो final mass of carbon is 4, carbon monoxide is 4. R bar is 8.314. R bar by molecular weight is 28, and the final volume of carbon monoxide is 2.0718, and the final temperature is 418. Whether you calculate from this side or this side, you get the final pressure. कितना आ रहा है सर? कितना आ रहा है फाइनल प्रेशर? एनीवन? सर आप लोग ना मजाक करके रखा है सर. वंडरफुल सर. 239 kilopascal. Whether you calculate from this or this, you get 239. So it is 2.39 bar. So let me check sir. बहुत enthusiasm से आया सर. 2.3. वाह! All the options are correct. मतलब in one question we have solved everything. That's why I have taken up this. बोलो खुश हो कि नहीं? सर इंटरनल एनर्जी चेंज राहुल साहू एमसीपी डेल्टा टी नहीं होगा सर, एमसीवी होगा. ठीक है सर. चलो लेट्स मूव टू द नेक्स्ट क्वेश्चन. मतलब इन द सेम क्वेश्चन वी हैव सॉल्व्ड 4 पैरामीटर्स. सेम क्वेश्चन 4 पैरामीटर्स. इसका मतलब पहले क्वेश्चन में 2, इसमें भी 2, 4, मतलब 6 क्वेश्चंस किए. चलो ये ले लो, खुशियां नहीं, ये वाला ले लो सर. मस्त क्वेश्चन है सर. प्लीज टेक दिस. Shall I continue? Third. Let me do this. बोलो रे बाबा, बाबा बोलो, खुशियानी. चलो, ये वाला लीजिए. Oh my God, uninsulated. This tank is not insulated. This tank is not insulated. Initially, tank A holds 0.45 kg of air. ध्यान से सुनो, इसमें भी air है, इसमें भी air है, कोई बात नहीं. But these are at different states. So, इसका pressure अलग है, इसका pressure, अच्छा pressure तो same है. Temperatures are different. ठीक है sir. Now what he says is, look at this mass is different, this mass is different. Okay. Now the valve is opened. Eventually the contents mix, and the final equilibrium temperature is 289. ध्यान से सुनो. This side there is air, this side there is air, and both are at different temperatures. And the valve is opened, and the contents are allowed to mix. कोई बात नहीं sir. Now देखो, the final equilibrium temperature is 289. दिया है problem में. Assuming ideal gas model, the energy transfer by heat and the final pressure is बहुत बढ़िया. कुछ मत करना सर, ये रिजिड टैंक है, ये रिजिड टैंक है। See the volume occupied by this pipeline, ये छोटे walls is negligible, तो this volume calculate करो, this volume calculate करो। It is a rigid container, it is a rigid container। Can I calculate the volume? My dear friends, PV is equal to MRT, तो volume तो आ जाएगा MRT by V। Wait, so I will write this as VA। देखो mass is given, air है, R is 0.287 kilojoule per kg Kelvin, the M is known, R is known, T is known, V is MRT by P, sorry, pressure is in kilopascal, M is देखो volume of the container है, M को 0.45 put करना, R को 0.287, okay, and temperature should be in Kelvin, it is 800, pressure is 345, so if we calculate volume of tank A, anyone, what is volume of tank A? कुछ नहीं बोल रहे रे, मैं देखूंगा सर, क्वेश्चन नहीं दिख रहा है, ओ क्वेश्चन नहीं दिख रहा है क्या? 0.298, 0.3 ले लेंगे सर, विल टेक इट एज क्वेश्चन दिखा है बाबू तनुज, दिख रहा है मेरे इसमें तो दिख रहा है सर, आई कैन सी सर। हाँ, इसका वॉल्यूम कैलकुलेट करो, वॉल्यूम ऑफ बी सेम, हाउ डू आई कैलकुलेट? MRT by P, M is known, R is known, T is known by P, तो अगर हम कैलकुलेट कर रहे हैं वॉल्यूम ऑफ बी is 0.37435 मीटर क्यूब, ठीक है, and what will be the total volume? The total volume is VA plus VB, so the total volume we can calculate VA plus VB, already this volume is 0.3, this volume is 0.299, I took it as 0.3, and this is 0.3 something, add, so the total volume is 0.67435. Now you may be wondering, sir मैं ये लेके क्या करूं? बहुत बढ़िया, any problems sir? Shall I proceed? चलो कोई बात नहीं, इधर देखो सर कैसे करें। One more thing, D dash Q is equal to DU plus D dash W, ठीक है सर। How much work are you getting? Anyone? This is a rigid container. Mixing में कोई work नहीं मिलता है आपको. You know very well. In mixing you don't get any work. Okay? Right. Now, therefore, they are rigid containers, and you are not getting any work from this. Now you are supplying any work. तो ये zero होगा. So can I write the heat transfer is equal to change in internal energy? Yes, sir. But this I write it as, look at carefully. सुनो carefully. What is du? It is the internal energy change of gas A and internal energy change of gas B. ठीक है sir. So heat transfer is equal to mCV delta T for tank A plus mCV delta T for tank B. ठीक है sir. Now I think masses are given. इधर का mass 0.45, उधर का 0.9, 0.45. इधर देखो D dash Q. So left side mass is how much? Tank A 0.45. So this is 0.45. What is CV? Air के लिए 0.718. Change in temperature. Final minus initial. What is the initial temperature in tank A? 800. So this is 800. Excellent sir. Plus. What is the mass in the right side? इधर देखो. Mass in the right side 0.9. It is 0.9. And what is CV for air? 0.718 into delta T. What is delta T? Final minus initial. What is the initial temperature? It is 500. So it is 500. ठीक है sir. And please look at, already the final temperature is given. कितना दिया sir? 289. इधर देखो sir. This final temperature is given as 289. यहाँ पे भी the final temperature is given. कितना है sir? It is 289. So everything is known except D dash Q. Anyone? It will be in kilojoule. Why kilojoule sir? M is in kg, CV is kilojoule per kg Kelvin. तो kg kg कट गया, Kelvin Kelvin कट गया, kilojoule. What is the heat transfer? Anyone? What is the heat transfer? No one is telling. What is the heat transfer? I'm waiting for your answer, sir. I'm waiting for your answers, sir. I am waiting for your answer, sir. I am waiting. Mine, very good. Spartan, Mayank. भगवान आपको मयांक गलत है. अरिंदम is correct. हरकराज, कार्तिकेय, प्राज्ञा, माइनस आ रहा है. Very good. The answer is minus 301.45. What does the negative sign show? It is heat rejection. So let me check option, sir. देखो, let me check option, sir. क्या दिया है? एक बार देखो. The heat transfer is, oh my god, this is wrong. There are two options with minus and I have to calculate the final pressure. Can anyone help me with final pressure? देखो एक बार. PV is equal to MRT. ध्यान से सुनो. Air इस साइड है. Both air contents they mix with each other. So I will apply final equilibrium temperature is 289. This is air. So therefore it is complete air at a new state. So what will be the mass, sir? Left side it is, look at carefully. Left side it is 0.45. Right side it is 0.9. And complete masses they mix with each other. This side. So 0.9 plus 0.45 is 1.35. Okay, and final temperature is known. So finally, it is in valve is open and they mix and equilibrium pressure is reached. So therefore, if you want pressure, it will be MRT by V. Some students wondered why this poor fellow calculated the volume. And you know, there is a tank A, there is a tank B. Both mix with each other, final volume आ जाएगा. Already we have calculated the total volume. So total volume, final equilibrium pressure, total mass, it will give you the final equilibrium pressure. So let us calculate. So 0.45 plus 0.9 is 1.35. Air के लिए R is 0.287. And what is the temperature? Final is 289 by volume. Final volume कुछ दिया था सर. Final volume मतलब total volume सारे mix होके equilibrium में. It is 0.67435. 0.67435. And this pressure will be in bar. Sorry, kilopascal. Why? Because R is in kilojoule per kg Kelvin. Can anyone tell the final pressure? Someone said 166. Someone said 166. क्या ये correct है sir? Excellent sir. 166 kilopascal is correct. बहुत बढ़िया, बहुत ही बढ़िया. तो options बताओ रे, बताओ. So 166 option C is correct. बहुत बढ़िया सर. एक एक क्वेश्चन में दो कर रहे. खुश हो कि नहीं? अरे अल्लाह, क्या हो रहा है मेरे बच्चों को? हरिनाथ जगन्नाथा. चलो लेट्स गो टू नेक्स्ट क्वेश्चन. वेस्ट नहीं करेंगे सर टाइम. ये पढ़ो एक बार. आई रिक्वेस्ट एवरीवन, इज द क्वेश्चन क्लियर? बहुत बढ़िया. प्लीज गो टू द नेक्स्ट क्वेश्चन. Go to the next question. Next question. Go to the next question. दिख रहा है सर आपको? 2 kg of a gas, ठीक है, with a molecular weight of 28 means I can write R is equal to R bar by 28, ठीक है, is are contained what is the mass given sir? It is 2 kilogram, ठीक है, in a closed rigid tank filled with electrical resistors. The resistor draws a current of 10 ampere and the voltage is 12 and the time is 10 minutes, ठीक है sir. Okay, when the equilibrium is, क्या बोल रहा है sir? Actually there is a closed container. In that closed container, there is a gas, 2 kg gas, and the molecular weight of that gas is 28. And we are supplying electric current to that. Can I say work is done on the system? बिल्कुल sir. देखो, ये electric, if this is the container and ये electrical resistance मान लो, तो electrical current, देखो electrical work. तो can I say work is plus or minus? इलेक्ट्रिकल वर्क अंदर आ रहा है, वर्क इज ट्रांसफर्ड टू द सिस्टम, इट इज डन ऑन द सिस्टम, इट इज डन। ओके, फर्स्ट लाइन नहीं दिख रहा है, क्या हो रहा है सर? मेरे इसमें तो सारा दिख रहा है सर, मेरे इसमें तो सारा दिख रहा है सर, कोई दिक्कत है? हाँ, वर्क इज नेगेटिव वर्क, तो वर्क कितना आ रहा है सर? वी आई, ध्यान से सुनो, इलेक्ट्रिकल वर्क वी आई तो कितना आएगा? 120 ना, 120। ठीक है सर, बोलो रे, बोलो, कहां गया? इज इट 120? यस 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 120। ठीक है, कहां गया वो? और बोल दिया, इट विल बी इन वाटर। ठीक है सर, पावर इज इक्वल टू वी आई, वी आई, वी आई, पावर इज इक्वल टू वी आई, वी आई 120 into 10 is this much, but this will be minus, why minus? Electrical work is done on the system। एक बार देखना, d dash q is equal to, अच्छा क्वेश्चन है सर ये, du plus d dash w। देखो, he clearly said heat transfer to the surroundings is estimated to occur at a rate of 20 watt। हीट ट्रांसफर सिस्टम से बाहर जा रहा है, देखो सिस्टम से बाहर जा रहा है, तो शुड आई टेक दिस हीट ट्रांसफर प्लस और माइनस? हीट ट्रांसफर टू द सराउंडिंग्स, सिस्टम से बाहर जा रहा है, तो इट इज -20 इज इक्वल टू du, एंड वर्क इज डन, इलेक्ट्रिकल वर्क इज डन ऑन द सिस्टम, दैट इज -120। बट इसका यूनिट वॉट में है, इसका भी वॉट में है, तो you get du as, why are you taking both negative? Because heat is rejected to surroundings and work is done on the system, so both are negative। Okay, so if you take 120 to this side, I think you are getting this as 100 watt। ठीक है सर, लेकिन पूछ क्या रहा है? The specific heat at constant pressure Cp is, so internal energy change is 100 आया सर। अब देखो, we got the internal energy change as 100, तो अब क्या करेंगे? सुनो केयरफुली, आराम से, कोई टेंशन मत लेना। देखो, लेट मी कन्वर्ट दिस, ये जो 100 वॉट है, कैन आई राइट वॉट एज जूल पर सेकंड? ध्यान से सुनो, कैन आई राइट वॉट एज जूल पर सेकंड? एक सेकंड के लिए इतना इंटरनल एनर्जी सिस्टम का इंक्रीज हो रहा है, बट इट इज रनिंग फॉर 10 मिनट्स, सो 10 मिनट्स का मतलब, सो टोटल इंटरनल एनर्जी चेंज आई विल कैलकुलेट, सो इट इज फॉर 1 सेकंड, फॉर 10 मिनट, मिनट का मतलब 60 सेकंड, अरे इट इज फॉर 1 सेकंड दिस मच चेंज, फॉर 1 सेकंड दिस मच चेंज, फॉर 10 मिनट, मिनट का मतलब 60 सेकंड, तो एनीवन विथ du कितना आ रहा है सर? 60 किलोजूल, am I right सर? Is it 60 किलोजूल? बोलो बोलो बोलो, बिल्कुल सही है सर, बट एवरीवन नोस, अरे यार ये देखो नहीं समझ में आ रहा सर, आपको नहीं समझ में आ रहा, सो ये क्या है सर? 1000 जूल को 100 into 10 is 1000 joule, can I write 1000 joule as kilojoule? Yes, 60 kilojoule, second कट गया, but what is du? It is mcv dt। क्लैरिटी से बोला है, the temperature of the gas is increased by, it's not increased to, increased to means final temperature, increased by मतलब change, how much is the change? delta t 40, increased by बोला है, increased by 40.3, तो should I take it in Kelvin? Oh my god, whenever it is difference in temperature, it doesn't matter whether it is in Kelvin or degree centigrade, तो आप Kelvin में convert करो या degree, temperature का difference है सर, ये it is increased by बोला है, whenever it is difference in temperature it doesn't matter, so therefore हम क्या करेंगे? it is 60, du is already 60, mass दे रखा है सर 2 किलोग्राम, cv I don't know, and what is the temperature difference? 40.3, यहां से I get cv, can anyone tell the value of cv? Anyone in the class, what is the value of cv? कोई नहीं बोलते रहे, 0.744 kilojoule per kg per Kelvin, but is he asking cv? Nah, he is asking cp, तो क्या करेंगे सर? I got cv as 0.744, ठीक है सर, cp minus cv is equal to r, and I want cp, that is r plus cv, ठीक है सर, but what is r? R bar by molecular weight plus Cv. So if you want Cp, what is R bar? 8.314, and the molecular weight is given as 28, plus Cv is 0.744, and please give me the value of Cp, so many kilojoule per kilogram per Kelvin. Please give me the value of Cp. Sir, आप आंसर नहीं दे रहे सर, molecular weight is given in the problem. हे हरिनाथा, जगन्नाथा, बालमुकुंद, सर आंसर चाहिए। I want answer. नहीं मिल रहा रे आंसर। क्या हो रहा है सर? नो वन इज गिविंग द आंसर। वेरी सैड। आई एम वेटिंग फॉर आंसर। मतलब यू आर नॉट रेडी विथ कैलकुलेटर्स। Yes, Mayank is correct. 1.041 is the right answer. Only Mayank Babu has given. Only Dr. Mayank अरिंदम दिया है, उसके बाद सत्येंद्र दिया है। बहुत बढ़िया, बहुत बढ़िया। सो ये भी अच्छा क्वेश्चन था सर। दिस वाज आल्सो अ गुड क्वेश्चन। ठीक है सर। गेट मैकेनिकल न्यूमेरिकल अब वो बाद में डिस्कस करेंगे सर। अब हमारे पास वो समय नहीं है। मैं आपको लास्ट में नंबर दूंगा, कॉल कीजिए सर। महालिंग राजा। चलो लेट्स गो टू द नेक्स्ट क्वेश्चन। ठीक चल रहा है या बंद करूं दुकान? इज इट गोइंग ऑन फाइन? इज इट गोइंग ऑन फाइन? क्या सही चल रहा है रे? क्या सही चल रहा है रे? अरिंदम 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 रे। ये लीजिए, मस्त क्वेश्चन लीजिए। मस्त स्टूडेंट्स के लिए मस्त क्वेश्चन रे। बेहतरीन, बेहतरीन, बेहतरीन। चलो लेट्स टेक दिस क्वेश्चन। Air is confined to one side of a rigid container. This container is a rigid container. Okay. Air is confined to one side of a rigid container. On one side there is air, and the other side there is vacuum, initially evacuated. The air is initially at 4 bar. Here the pressure is 4 bar, and the temperature is 600, and the volume is 0.25. Here the conditions are. When the partition is removed, इस partition को हम हटा दिए। There is a partition here. मित्रों, मेरे प्यारे मित्रों, यहाँ पे एक partition है। सुनो रे, छोटा सा partition है। मित्रों, there is a partition. मेरे मित्रों, तो इस partition को हम ध्यान से सुनो, इस partition को हटा दिए। After you remove the partition, this air will expand completely. Air will expand completely. लेकिन यहाँ पे एक problem है सर। What is the problem? This container is not insulated. Did he say? कहीं पे बोला है ना? और क्वेश्चन में भी ये भी पूछा है, the heat transfer is means this container is rigid है, उसमें कोई शक नहीं है, but it is not insulated. So when this partition, there is a vacuum on other side. When the partition is removed, this air will occupy the complete volume in the final state. And clearly he said the final pressure is 1/4 of the initial pressure given. The final volume is twice the original volume. So this is V, this is V, this is V. Total final volume is twice of the initial volume. अब क्या बोल रहा है सर? इधर देखो. What is the final temperature? What is the heat transfer? चुपचाप बैठो. This air is expanding. It is expanding against what? मित्रों, it is expanding against what? Vacuum. What is the work transfer? Anyone in the class, what is the work transfer? Anyone in the class, what is the work transfer? Work transfer के लिए there has to be some resistance. So if I am lifting this bottle, it is मतलब इसका weight oppose कर रहा है, तो उस resistance को overcome करने में work करना चाहिए सर. Larger the resistance, larger is the work. On this side there is vacuum, no material medium. So this air has no resistance. So I can say that the work transfer is 0. ठीक है. Now, I can write d dash q is equal to du plus d dash w. Excellent, sir. Already work is zero. So whatever the heat transfer is taking place, it is nothing but change in internal energy in this case. But यहाँ पे careful रहो. क्या careful, sir? ध्यान से सुनो. How can I find the final temperature? मित्रों, how can I find the final temperature? Let me explain very clearly. कुछ नहीं है, sir. Originally, our air was occupying this small volume, and finally, the same mass of air is occupying total volume. So, this side we have nothing, no material medium. So, can I equate the mass of air under these conditions is equal to mass of air under this? Under this condition, yes, mass conservation. So, पहले इतना occupy कर रहा था, same mass is occupying this much volume. So, mass is neither added nor removed. The same mass is expanding. So, PV is equal to mRT. So can I write this as, dear students, M is equal to PV by RT? Yes, sir, why not? So I will write this as PV by RT under initial conditions is equal to PV by RT under final conditions. But this is air. For air, R is same. So R को cancel कर देना. So I will write this as P1 V1 by T1 is equal to P2 V2 by T2. Excellent, sirs. So P1 V1 by T1. What is T1? 600 is equal to P2. But देखो P1 V1 by T1 is P2 V2 by T2. What is P2? P1 by 4. And what is V2? What is V2? Twice V1. ठीक है sir. By P2 V2. P2 is P1 by 4. V2 is twice by T2. ठीक है sir. Excellent. This P1 V1, this P1 V1 is gone. So ये 2 ones, 2 twos, 2 ones 300. So the final temperature is 300 Kelvin. तो यहाँ पे 300 Kelvin. चलो 300 Kelvin. So 300 Kelvin का मतलब 27 degree centigrade also. मतलब ये भी सही है, ये भी सही है. देखो 300 Kelvin, अरे 0.372 को छोड़ दो. 300 Kelvin is also 27. मतलब ये भी सही है. ठीक है सर. How to calculate heat transfer? Heat transfer in this case is change in internal energy. देखो, in this case, heat transfer is equal to change in internal energy. Why the work transfer is zero? So mCV T final minus T initial. Excellent, sirs. Unfortunately, I don't know mass. How to calculate mass? मुझे तो पता है same mass. P is given, V is given, T is given. देखो, mass calculate करो. PV by RT. तो mass is equal to pressure is 400 kilopascal. Suno sirs, 400 kilopascal, and volume is 0.25 by R 0.287 into temperature is 600. ध्यान से सुनो सर, यहाँ सब पता है. I can calculate mass. If I am calculating mass, मुझे mass आ रहा है 0.5807. So when I am calculating the mass, it is coming out to be 0.5807. And for air, is it air, sir? Is it air? Yes. For air, CV is 0.718. Just now you calculated the final temperature as 300. And what is the initial temperature? Initial temperature is 600. The initial temperature is 600. So everything is known. I'll get the heat transfer. Anyone? Anyone with heat transfer? Spartan has given the answer. मजा आ रहा है सर. Spartan को पढ़ा के मजा आ रहा है सर. स्पार्टन को पढ़ा के मजा आ रहा है सर. 125 पॉइंट. अरे तनुज है रे तू जिंदा रहने की मौसम. क्या है रे आंसर, क्या है रे आंसर. व्हाट डज नेगेटिव साइन शो? ओके, बहुत बढ़िया. मयंक ने पूछा वेयर इज द हीट ट्रांसफर अकरिंग. चलो कोई बात नहीं. व्हाट इज द टेम्परेचर हियर? 600 केल्विन. इज दिस इंसुलेटेड सर? एंड इट इज एक्सपैंडिंग. समझ में आ रहा है? तो क्या होगा? इट इज एट हाई टेम्परेचर. दिस सराउंडिंग मे बी एटमॉस्फेरिक, वहां से जा रहा है. ठीक है, ठीक है, ठीक है, कोई दिक्कत नहीं. Let's go to the 7th question. आप थोड़ा 7th question पे concentrate करें. 6th है, 7th है, 6th है, 7th है. कितने किए रे हम? कितने किए रे? फिफ्थ किए, छठवां कहाँ है? हाँ, गायब कर दिया देखो आदमी, देख सेकंड, गया। हाँ चलो कोई नहीं, पढ़ो एक बार। डियर स्टूडेंट्स पढ़ो, प्लीज रीड द क्वेश्चन, प्लीज रीड द क्वेश्चन। इसको थोड़ा चार्जिंग लगाते हैं। An ideal gas undergoes two processes in a piston cylinder device. 1 to 2 is a polytropic compression with an exponent n, and the compression ratio is V1 by V2. 2 to 3 is a constant pressure expansion until V3 is V1. The expression for the ratio of work of compression to the work of expansion. सवाल देखो सर, 1 to 2 is polytropic compression. 2 to 3 is, एक second please, is constant pressure expansion. Let me try to plot this. चलो कोई बात नहीं सर, please listen on PV diagram. Actually, what is the question I tell you? This is the polytropic compression, okay? And let this volume be V1. And finally he said 1 to 2 is a compression, ठीक है? And 2 to 3 is a constant pressure expansion, means the volume is increasing from like this. Clearly he said the final volume is equal to this volume. Clearly बोला है sir. He said V1 is equal to V3. ठीक है? This is given. And you also know the pressure here, P2 is equal to P3. No problem at all. So P2 is equal to P3. ठीक है? Now he is asking what is the ratio of this work to this work. So he is asking work in 1 to 2 to work in 2 to 3. But he has given in terms of some Rn. But what is R, sir? R, he said compression ratio. What is the meaning of compression ratio? It is volume before compression to the volume after compression. Volume before compression to the volume after compression. It is known as compression ratio. ठीक है sir. Can anyone tell what is polytropic work? It is P1 V1 minus P2 V2 by n minus 1. Is it correct sir? Yes, it is correct. तो एक सेकंड इसको थोड़ा रीअरेंज करेंगे. Let me take P2 V2 outside. I repeat, let me take P2 V2 outside. Already there is n minus 1. So this can be written as P1 V1 by P2 V2 minus 1. Excellent sir. Is there any difficulty sir? From this I took P2 V2 bahar. So P2 V2 by n. Okay. Now can I write P1 V1 power n is equal to P2 V2 power n? Because 1 to 2 is polytropic process. So therefore, I can write P1 by P2 as V2 by V1 power n. ठीक है sir. So what is P1 by P2? इधर ध्यान से देखो. My compression ratio R is V1 by V2. But here उल्टा है sir. Can I write this as 1 by R? This is 1 by R. 1 by R power n is 1 by R power n. ठीक है sir. So I will write the work in 1 to 2 as P2 V2 by n minus 1. देखो P1 by P2. What is P1 by P2? P1 by P2 1 by R power n into V1 by V2. What is V1 by V2? It is R. ठीक है sir. Minus 1. So I will write this work for 1 to 2 as P2 V2 by n minus 1 into, so this is power 1, so I will write this as R power, देखो ये ऊपर जाएगा -1. लेकिन ये वर्क नेगेटिव वर्क है सर. Why? Because it is compression work. Yes or no sirs? अरे यार मैं आपका ये देख रहा हूँ, कहाँ गया रे, गया रे. क्लियर? बहुत बढ़िया सर. ये आ गया. This is the work in 1 to 2. But actually this work is negative. तो अगर हम मैग्नीट्यूड चाहिए तो क्या होगा, माइनस ले लो, चलो कोई बात नहीं. 1 to 2. Then what is 2 to 3 work? Anyone? What is 2 to 3 work? 2 to 3 is a constant pressure work. This is 2, this is 3. This volume V3 is equal to V1 and this volume is V2 already given, and I will write this as P2 is equal to P3. Everyone knows constant pressure work is work in 2 to 3 is equal to pressure which is either P2 or P3 chalo into final volume minus initial volume. ठीक है sir. So work is equal to, आराम से कोई टेंशन नहीं sir. Can I write this as, सुनो carefully, इसको ऐसे करेंगे, P2 लिखो, V3, what is V3? V1 minus V2. Because he has given V3 and V1 are same. देखो एक बार, V3 and V1 are same. So what is this work? P2 into V3 minus V2. But V3 is V1. So therefore, I will write this as work in 2 to 3 as P2, V2 को बाहर ले लेना. You take V2 out. So it will be V1 by V2 minus 1. So therefore, work in 2 to 3 is equal to P2 V2. What is V1 by V2? Compression ratio R minus 1. ठीक है. I got work in 2 3. I got work in 1 2. Let us calculate the ratio. He is asking this only. एक बार देखो sir. What is work in 1 to 2? Work in 1 to 2. P2 V2 by N minus. देखो. P2 V2 by N minus 1. P2 V2 by N minus 1 into P2 V2 by N minus 1 into R power 1 minus N minus 1. R power 1 minus N minus 1. ठीक है. By work in 2 3. What is work in 2 3? P2 V2 R minus 1. So P2 V2 गया. So the work ratio 1 to 2 to 2 to 3 is given by R power 1 minus N minus 1 by N minus 1 into R minus 1. यही तो पूछा था. लेकिन actually minus आता है क्योंकि ना this work is negative. So is it clear? Is the question clear, my dear students? My dear students, is the question clear? एक बार options देखेंगे sir. I think we are getting yes. ये वाला बिल्कुल सही है सर. माइनस आया हमें because the compression work is negative. This one is correct. Yes, I got this. Yes, I got this. Is the question clear sir? Yes, this one is correct. B option is correct. कुछ तो बोलो सर. कुछ तो बोलो सर. Is it correct? Is it correct, my dear students? Yes, my dear students. Yes. Let's go to the next question. ये वाला लीजिए. Seventh question. A room contains 75 kg of air at 100 kilopascal, 15 degrees centigrade. The room has 250 watt of refrigerator. चलो. Then 120 watt of TV. चलो. 1.8 kilowatt of electrical heater. Can I write this 1.8 kilowatt as 1800 watt? बिल्कुल sir. I have converted all into semi-unit. And 50 watt of fan. There are 4 devices in a closed room. All these 4 they consume what sir? ये सारे 4 क्या consume करेंगे? Electrical energy. That means there is an external energy input because electrical wires are coming. So ये total work कितना होगा sir? Add करो. You add this total work. All these are electrical works. 2, 1, 3, 4. Is it correct? Very good. This much of electrical work. So I will write this as minus 2220 watt. एक बार बोलो सर. Minus 22. Exactly. तो आप बोल क्या रहा है सर? This is a very good question sir. What is the rate of heat loss from the room? देखो. But one sentence is given. What is that sentence? But the temperature in the room remains constant. Room में क्या है? Air. रूम में क्या है? एयर. एयर कैन बी ट्रीटेड एज आइडियल गैस. ठीक है सर. तो द टेम्परेचर इज कांस्टेंट. देखो एक बार. द टेम्परेचर इज कांस्टेंट. इंटरनल एनर्जी ऑफ एन आइडियल गैस इज द फंक्शन ऑफ टेम्परेचर. व्हेन टेम्परेचर इज कांस्टेंट, internal energy is constant. When internal energy is constant, the change in internal energy is zero. So d dash q is equal to du plus d dash w. तो du तो जीरो होगा सर. du तो हीट ट्रांसफर इज इक्वल टू वर्क ट्रांसफर. एक्सलेंट सर. तो हीट ट्रांसफर इज इक्वल टू, इधर देखो वर्क ट्रांसफर. व्हाट इज द वर्क ट्रांसफर? -2220 watt What does negative sign show? Heat rejection. But unfortunately, the answer is not in watt. देखो, -2220 watt. watt का मतलब जूल पर सेकंड. ध्यान से सुनो. ये किसमें पूछा है सर? आवर में पूछा है. आवर में. So 1 second can be written as, अगर आपको आवर में 1 सेकंड के लिए this much is the heat transfer. For 1 hour multiply with 3600. So therefore 2220 into 3600 joule per hour. Excellent sir. तो 222 is it correct sir? सही है या गलत है? 222 करेक्ट बिल्कुल करेक्ट है. ओके, इज इट 222? आई थिंक ये 220 आ रहा है ना. 222 करेक्ट है ना. हाँ, तो ये आ रहा है कितना आया सर? दिस इनटू दिस. आई थिंक यू आर गेटिंग दिस एज 7992 into 10 power 3 joule per hour. What is 10 power 3? kilojoule per hour. I think B is the right answer. Is it correct? क्या B सही आ रहा है सर? चलो नेक्स्ट क्वेश्चन. हाँ लीजिए सर. come on come on come on come on come on come on, ये वाला लीजिए. 8th one. ये भी हो गया. नेक्स्ट क्वेश्चन कौन सा है? ये वाला ना. how good है? where is that? चलो ये वाला कर लेंगे. A piston cylinder device whose piston rests on set of stops initially contain 3 kg of air at 200 kilopascal and 27 degrees centigrade. The mass of the piston is such that a pressure of 400 is required to move it. Heat is not transferred to air until the volume doubles. Which of the following is correct? ये अच्छा क्वेश्चन है सर. Okay, what is the initial pressure? 200. मुझे बताइए सर. कूली देखो. The initial temperature is 27 degrees centigrade. The pressure is 200 and mass is this. क्या बोल रहा है? Heat is supplied. Immediately after the supply of heat ये उठेगा? नहीं सर. First it will absorb. Then it gets lifted up. Means initially the piston is not moving. Means initially this volume is constant. There are two processes occurring. मस्त क्वेश्चन है सर. इसको मैं बहुत अच्छा बताऊंगा आपको. ये मस्त क्वेश्चन है सर. मुझे बताइए सर. Immediately after the supply of heat, will the piston rise? Immediately after the supply of heat, will the piston rise? No. Because sufficient heat is required. So temperature बढ़ने के बाद collisions बढ़ेंगे. जब collisions बढ़ेंगे, जब pressure धीरे से क्या होगा? बढ़ेगा. कहां से? 200 से 400 तक. तो now I can say the system is undergoing two processes, sir. Look at carefully. Two processes. Initially the volume is heat is supplied, but the volume is constant. तो अब देखो. तो now I write it as 1 to 2. उसके बाद क्या हो रहा है? Now the piston is getting lifted up. How long? Until the volume is doubled. तो this is the process. देखो, until the volume is doubled, can I write V3 as 2 times V1, and here V1 is equal to V2, and this is the pressure constant. ठीक है sir. What is this pressure given? Initial pressure. Initial pressure is 200, and the final pressure. देखो, एक सेकंड देखो. Initially it is at 27 degrees centigrade. Let me repeat the question, sir. Sir, आपको क्वेश्चन समझ में आया सर? कहाँ पे है रे हम? समझ में आ रहा है सर आपको? My dear students, have you understood? Have you understood? Arindam? बोलो. यस, वेरी गुड. यही क्वेश्चन गेट में आया था जो मैं करवाया था. चलो सुनो सर, अब कैसे करेंगे सर? बहुत कूली देखो, piston cylinder device whose piston rests on the stops initially contains air at 200 kilopascal. Initially it is at 200 kilopascal. This is the volume. Now we are supplying heat. So after the supply of heat, after some time, taking it, but the piston is resting on stop, so therefore it is a constant volume. But temperature is increasing. After some time, now the piston is getting lifted up. Cup when the pressure is 200, so 400 हो गया. When the pressure is 400, तो यहाँ से now you tell me, once the piston starts moving, it is a constant pressure process. बहुत बढ़िया. क्या ये डायग्राम समझ में आया सभी को? प्लीज बताइए, क्या ये डायग्राम समझ में आया सर? ठीक है, वेरी गुड. अब देखो क्या पूछ रहा है. Which of the following statements are? हाँ, heat is not transferred until, मतलब इसमें भी heat supply हो रहा है, इसमें भी heat supply हो रहा है. I told you very clearly. Whenever the constant volume moves up, heat supply. Whenever constant pressure moves right, heat supply. चलो. The work done by A is, anyone in the class? What is the work done in 1 to 2? In constant volume, there is no work. So what is the work done in, देखो, initial volume हम calculate करेंगे ना रे? Until the final volume कितना थे? Volume until the final volume is doubled. ठीक है? तो can I calculate the initial volume, sir? क्या मैं initial volume calculate कर सकता हूँ सर? इधर देखो, initial volume PV is equal to MRT. तो volume is equal to MRT by P. So what is the initial volume? The mass is 3. For air, R is 0.287 and temperature should be strictly in Kelvin, 300, and the pressure is 200. So if I calculate the initial volume, I am getting this volume as 1.2915. So what will be the final volume? Double of this, 2V1. 2V1 होगा. It will be 2.583. अब बताओ. He is asking the total work. In this the work is 0. There is a work, constant pressure work. So if you want work in 2 to 3, there is no work in 1 to 2. It will be pressure. This pressure is 400 into change in volume. अरे यार इसको प्रोजेक्ट कर देना. ये area calculate करना. You get the work. So what is this pressure? 400. And change in volume is 2V1. देखो 2V1 minus V1. तो कितना आ रहा है सर? 400 into 2V1 minus V1 is V1. What is V1? 1.2915. So how much is this, sir? How much is this, sir? 516.6. Is it a positive work or negative work? Anyone in the class? Is it a positive work or negative work? Is it a positive work or negative work? It is a positive work, sir. It is a positive work. Why it is a positive work, sir? Because the gas is expanding. Because the gas is expanding. The gas is expanding. So it is a positive work. 516. So D is correct. Lekin question is not over, sir. Question is not over, sir. He is asked, it is MSQ, sir. Work done by A is ये गलत है. This is wrong. This is wrong. Now he is asking total heat transfer. Total heat transfer means heat transfer in this plus heat transfer in this. Let me do this. देखो, total heat transfer is equal to heat transfer in 1 to 2 plus heat transfer in 2 to 3. ठीक है सर. इधर देखना सर. What is 1 to 2 process? What is 1 to 2? It is a constant volume. For constant volume, it is change in internal energy. For constant pressure, it is change in enthalpy. ठीक है सर. No problem at all. So heat transfer is given by, बहुत careful देखो, mCV T2 minus T1 final minus initial plus DH is mCP final minus initial. नहीं आ रहा सर आपको? अरे यार, for 1 to 2 final is 2, initial is 1, T2 minus T1. For 2 to 3 final is 3, initial is 2. So therefore I wrote this, no problem. Is the mass given, sir? Is the mass given? कहाँ दिया है? 3 kg दिया है. कोई दिक्कत नहीं सर. देखो, now there is a problem, sir. None of the temperatures are known. मुझे सिर्फ T1 पता है सर. सिर्फ initial temperature is known. Initially the system is at 300 Kelvin. Initially the temperature is 27 degrees centigrade. It is 300 Kelvin now. क्या कोई मुझे हेल्प कर सकते? Can anyone support me with what is this? ये 200 kilopascal है. And what is this? It is 400. This is V1 and this is V3, which is 2V1. Can anyone help me? क्या कोई मुझे बता सकते सर? T2 T3 इधर देखो 1 to 2 is a constant volume. PV is equal to MRT. I am applying for 1 to 2. 1 to 2 is a constant volume. When volume is constant, mass is constant, pressure is directly proportional to temperature. So P2 by P1 is equal to P2 by P1. P2, what is P2? 400. And what is P1? 200. 400 by 200 is T2 and P1 is already known 300. तो कितना आ रहा है सर P2? 600 Kelvin. ठीक है सर. Similarly, 2 to 3 is a constant pressure process. इधर देखना. PV is MRT. When pressure is constant, R is constant, volume is proportional to temperature. So V3 by V2 is equal to T3 by T2. What is V3? What is V3? Twice V1. What is V3? Twice V1. And what is V2? नहीं आ रहा समझ में. V2 is also equal to V1 because 1 to 2 is a constant volume. 1 to 2 is a constant volume. तो V2 को मैं V1 लिखूंगा and T3, V3. What is V3? Twice V1. ठीक है. Is equal to T3 and already we know T2. T2 is 600 Kelvin. So ये गया. तो T3 is equal to 1200 Kelvin. All are known. देखो M. अब इसमें पुट करेंगे सर. M कितना दिया सर? What is M? M 3 kg. So therefore, M is 3 kg. CV is 0.71. Is it air? Is it air, sir? Air. Very good. Air. CV is 0.718 into T2. T2 is 600 and T1 is 300 plus M is 3. CP is 1.005. T3 is 1200 and T2 is 600. Here T3 is 1200. So I can calculate the heat transfer. Itna aaya sir. What is the heat transfer? Anyone in the class? What is the heat transfer? What is the heat transfer? I am waiting for your answers. Two four. Someone give the answer. 2-4. कहाँ गया रे? कोई नहीं दे रहा आंसर. 2455. Should be correct. Correct. बहुत बढ़िया. We'll go to the next question. बोलो बोलो. कितने क्वेश्चंस किए? सॉल्व इन ऑर्डर. बोलो बोलो. चलो ये वाला लीजिए. प्लीज रीड द क्वेश्चन. नहीं चेक करेंगे. 4xy plus 4y square 2x square plus 8xy. ओके. हाँ वो दिया है सर. देखो एक बार वो क्या दिया है. dz is equal to, he has given, let me read the question. dz is equal to 4xy plus 4y square dx plus 2x square plus 8xy dy. ये दिया है सर. एक बार देखेंगे. 2x square plus 8xy dy. अब पूछ रहा है is it a property? Is it a property? Is it a property? कैसे करेंगे सर? मैं बोला था if z is a property, if dz is equal to mdx plus ndy. बहुत carefully देखो. If z is a property, what is the condition? Dou m by dou y at constant x should be equal to dou m by dou x at constant y. See, please observe this equation exact differential होने के लिए मतलब प्रॉपर्टी होने के लिए दिस इज द कंडीशन. इज इट करेक्ट सर? Is it conditions? Is it correct, sir? Kishore said it's not a property. Let me check, sir. Okay, compare करो. D's and D's. This is M. This is N. Now, what is dou M by dou Y? देखो, dou M by dou Y. Dou M by dou Y. Let me check, sir. 4x square plus 4y square. 2x square plus 8xy. Correct. Is it a property, sir? देखते हैं, sir. Dou M by dou Y. This is M. So M is equal to 4xy plus 4y square. So what is dou M by dou Y, sir? What is dou M by dou Y? Dou M by dou Y is 4x plus y square. When you are differentiating with y, x is treated as, it is partial, so x is constant. Dou M by dou Y is 4x plus y. But the y square is 2y. So y square is 2y, so 8y. This is dou M by dou Y. Let's check n. What is n, sir? 2x square plus 8xy. अब बताओ सर, dou n by dou x क्या होगा सर? Differentiate करो with respect to x. It is 4x plus, it is with respect to x. Why should be treated as constant? अरे यार, it is with respect to x. 2x square 2x square is 2x 4x plus it is with respect to x 8y. So are they same? Are they same, my dear students? Are they same? Yes, they are same. When they are same, it is an exact differential. It is an exact. So whenever it is an exact differential, it is a property. देखो एक बार ऑप्शन की तरफ जाना. It is a property. Yes, Z is a property. Option देखो. The following quantity Z is a property. The following Z is not a property. ये गलत है. ये सही है. Hard question नहीं हुआ sir. If Z is a property, then Z can be written as पूछा है सर. ये अच्छा है सर. He says if Z is, see, we have found that Z is a property. हमने बोला Z property है, लेकिन Z का वैल्यू पूछा है सर. ध्यान से सुनो. अब मैं बताता हूँ सर. Now I will tell you how to calculate. What is the value of M, sir? मैं बताता हूँ. He is asking us to calculate it. ये थोड़ा मैथमेटिक्स है सर, लेकिन पूछ सकता है. M का वैल्यू क्या है सर? M is 4xy plus 4y square. N is 2x square plus 8xy. ठीक है सर. ध्यान से सुनो. dz is equal to mdx plus ndy. Any problem, sir? Any problem, sir? Yes, second part is very important, sir. Second part is very important. We have seen that it is a property. If it is a property, what is the value of z? थोड़ा मैथ्स में बताऊंगा. This is expected one. थोड़ा देखो. If I want z, what should I do? Integrate करो. अरे it is in differential form. If you want z, you integrate this. तो m dx plus n dy. अब simple mathematics है सर. इधर देखो. So please look at m. What is m? 4xy plus 4y square dx. बहुत बढ़िया. Plus n dy. What is n? 2x square plus 8xy, okay, into dy. Excellent sir. ध्यान से सुनो. Actually ये क्या है ना सर? mdx. ये इंटीग्रेशन इज विथ रिस्पेक्ट टू x है. अगर इंटीग्रेशन x के रिस्पेक्ट है, y should be treated as constant. अब देखो एक बार. 4 y should be treated as constant. What is x dx? x square by 2 plus 4y square. ये कांस्टेंट है. इंटीग्रल dx इज x. वेरी गुड. ये पोर्शन होगा. इसका बताओ 2x स्क्वायर इंटीग्रल dy, ये इज विद रिस्पेक्ट टू y, तो y होगा प्लस 8x y dy y स्क्वायर बाय 2. ये इसका पोर्शन होगा. इधर देखो सर, प्लीज लिसन. कैन आई राइट दिस एज 2x स्क्वायर y? यस सर. प्लस 4xy स्क्वायर. यस सर. ये वाला देखो 2x स्क्वायर y प्लस ये 4 होगा 4xy स्क्वायर. ठीक है सर. 2x स्क्वायर y 4xy square. Are they same, sir? Are they same, sir? Are they same? Yes. Whenever you get double, हम मैथ्स में क्या करते हैं याद है? एक ही बार लेते हैं. I don't know whether you have studied partial differential or not. Whenever you get double, you take single. Whenever you take double, you get single. तो ये 2x square दो बार आया, तो z is equal to मैथ्स की है सर. ये मैथ्स का कॉन्सेप्ट है. तो पार्शियल डिफरेंशियल का 2x square दो बार आया, तो we take once. प्लस 4xy स्क्वायर 4xy स्क्वायर दो बार आया, एक बार लेते हैं. दिस इज द वैल्यू ऑफ z. मस्त क्वेश्चन है सर. सो प्लीज अंडरस्टैंड, ये सिंपल मैथ्स है सर. अब मुझे ब्लेम मत करना. सो व्हेनेवर यू गेट ट्वाइस यू टेक सिंगल. सो देयरफॉर 2x स्क्वायर y 4xy स्क्वायर, 2x स्क्वायर y 4xy स्क्वायर, 2x स्क्वायर y 4xy स्क्वायर. आई थिंक दिस इज करेक्ट. प्लीज बताइए, आर वी क्लियर सर? 2x स्क्वायर y 4xy स्क्वायर. सिंपल मैथ्स है सर. क्या ये समझ में आया सर? बहुत बढ़िया सर. मैं आगे बढ़ सकता हूं सर? प्लीज टेल मी, इज इट क्लियर? मस्त चल रहा है, कोई टेंशन नहीं है सर. मस्त चल रहा है, कोई टेंशन नहीं है सर. अब ये वाला सवाल लीजिए, ये वाला लीजिए सर, ये वाला लीजिए सर. मस्त, ये वाला लीजिए. टेक दिस, टेक दिस, टेक दिस. Yes, Pankaj, right. Yes, you are right. ठीक है, ये वाला लीजिए. दिख रहा है सर? कैन यू सी द क्वेश्चन? कैन यू सी द क्वेश्चन सर? क्वालिटी क्या हो रहा है? मेरे में नहीं दिख रहा है. तो कैन यू सी सर? ओके. ए हीट इंजन, इसको क्या कर, दिख रहा है सर? नेटवर्क मिसप्रिंट हो रहा है. कहां पे नेटवर्क, कहां पे मिसप्रिंट हुआ सर? डू यू वांट मी टू रीड द क्वेश्चन सर? डू यू वांट मी टू रीड द क्वेश्चन सर? नेटवर्क मिसप्रिंट है. नेटवर्क कहां पे है? कहां पे नेटवर्क है? कहां बोला है? देखो, हीट इंजन ऑपरेटिव. ओके, नेटवर्क आउटपुट कहां मिस हो रहा है सर? दिख रहा है ना? इट्स क्लियर ना? इज इट 0? ओहो, 400. आई एम सॉरी, ये मिसप्रिंट है सर. मिसप्रिंट है. ये 400 सर. नेटवर्क इज 400. यू आर राइट. नेटवर्क इज 400. लुक एट केयरफुली. देयर इज अ हीट इंजन. It is running. अच्छा क्वेश्चन है सर. I don't say extraordinary, but अच्छा क्वेश्चन है सर. There is a chance of committing mistake. Engine is producing some work. Okay. Are you supplying the entire work produced by the engine to the refrigerator? No. देखो, इसको केल्विन में कन्वर्ट करो. 627 कितना होगा सर? 900 ना? 900 केल्विन. ठीक है. इसको केल्विन में कन्वर्ट करो सर. कितना रहे? 273. कितना रहे? मैं भी पागल हूं, तुम भी पागल है. आ गया वो? ये कितना आ रहा है? 320 आ रहा है. यस. अब देखो, कैन आई कैलकुलेट द मैक्सिमम एफिशिएंसी ऑफ दिस? इस इंजन का, इंजन का मैक्सिमम एफिशिएंसी यू नो 1 minus T lower by T higher. Higher is 900. I repeat sirs, 1 minus T lower by T higher. तो the maximum efficiency of the engine कितना आ रहा है सर? It is 0.644. But वहां पे एक twist है सर. What is the twist? इधर देखो. The efficiency of engine and the COP of the refrigerator are 40% of their maximum possible. So what is the actual efficiency, sir? The actual efficiency is 40% of maximum. 40 is 0.4 times maximum. It is 0.644. कितना आ रहा है सर ये actual efficiency? Anyone? What is the actual efficiency? The actual efficiency is 0.2576. Wait. And he also said how much heat engine is taking. देखो paper. Somewhere it is given. The heat transfer to the engine is 2500. This is given as 2500 sir जी. ठीक है. तो can I calculate? Already efficiency is given. So I don't take maximum efficiency, take actual. The actual efficiency is equal to, the actual efficiency is output, that is W1, by input 2500. So W1 by 2500. I repeat my dear students. The ideal efficiency or Carnot efficiency is calculated, but it is operating on 40% of maximum. So I calculated actual efficiency. From actual efficiency I get network by input. Input is given, so from that I get network. developed by the engine. And how much is that work? This work is 644. My question to you people is, if it is 644, what is the rejection to this? Here rejection to 47 degrees centigrade कितना होगा? 81. What is the rejection? 2500 minus this heat. ये heat चाहिए. Out of 2500, 644 is work. Out of 2500, 644 is work. Remaining is rejection. 25 minus 644, it is rejection. कितना आ रहा है ये? 1856. ठीक है सर. My question to you people is, what will be the work to this refrigerator? Anyone? What will? Out of 644, 400 is the network. 400. तो इसको कितना सप्लाई करें सर? 244. अरे सुनो रे. This engine is developing 644. Out of 644, 400 is network. तो how much work is supplied to this? नहीं आ रहा सर आपको. Out of 644, 400 तो net मिल रहा है. बाकी का कितना है? 244. That is given to refrigerator. ठीक है. Let us calculate the maximum COP of the refrigerator. It is lower temperature by higher minus lower. So let's calculate the maximum COP. ठीक है sir. What is the lower temperature? Minus 13. Don't put minus 13. 273 minus 13 is 216 by temperature difference. Whenever it is temperature difference, no need to convert in Kelvin. Self temperature difference, degree centigrade or Kelvin. 47 minus of minus 13. कितना होगा sir? I think it is 60. So what is the maximum COP, my dear students? बोलो बोलो मित्रों. What is the maximum COP? What is the maximum? कुछ नहीं बोल रहे आप लोग. मुझे दुख लग रहा है sir. 4.33. But what is the actual COP? Clearly he said the actual COP is 40% of maximum. It is 0.4 times maximum is 4.33. So the actual COP is equal to 1.733. ठीक है sir. So now you know that COP is equal to, the actual COP is equal to refrigeration effect. इसको RE लिखेंगे. Refrigeration effect by work input. So the actual COP is 1.733. ये refrigerator है is equal to RE. This is RE. By input to this is 244. So I get RE. What is the value of RE? If I am calculating RE, anyone कोई भी कुछ नहीं बोल रहा sir. I think it is 422.8. But easy asking is nah. It is 422.8. This is 244. How much is rejected to this? This is entering. This is entering. ये RE calculate किए. 422. This plus this add करो तो total आ रहा है कितना आ रहा है सर? ये 666.8. बट क्या पूछ रहा है? 47 डिग्री सेंटीग्रेड को कितना हीट रिजेक्ट हो रहा है? तो this is rejected to 47. This is also rejected to 47. You add both. This plus this. नहीं आया मित्रों. नहीं आया मित्रों. किसी को तो आया सर. क्या हो रहा सर? He is asking what is the net means total heat transfer to reservoir at 47. This is 47 to 666. This is 47 to 1856. 1856 plus 666 कितना आ रहा है सर? 2522 is the right answer. 2522. 2522 or something like this. 2522 is the right answer. Good question, sir. I don't say extraordinary, but a good question. मित्रों, no problem sir, there is no job through GATE exam, please you quit, kindly you quit. Mr. Tiger, please you quit. I have no problem, you can leave sir. With due respect, you can leave sir. When there is no job, please leave. People have come here to pursue MTech in IITs and ISC by taking XC exam, so you can leave sir. Humbly I am requesting, please leave. चलो कोई बात नहीं. नेक्स्ट क्वेश्चन ये वाला लीजिए. हाँ जी, कोई बात नहीं सर. I respect you people. You people are भगवान. I have no problem sir. मुझे कोई प्रॉब्लम नहीं है सर. आप मुझे गालियां दीजिए, आप मुझे कुछ भी बोलो, पागल बोलो, मुझे कोई फर्क नहीं पड़ता. I swear, I crossed all this. मुझे कोई फर्क नहीं पड़ता है सर. मुझे एक ही है कि I have decided to teach you some beautiful questions. That's it. My aim is very clear. माफ करना सर. If I do not fit for you, please leave the class. I never asked you to come. Please, white tiger, you are a tiger. I'm a fool, so don't worry. चलो कोई बात नहीं. Let's take 11. I don't mind sir. आप भगवान है आप लोग. मुझे कोई चिंता नहीं है सर. I'm a simple, एक ऑर्डिनरी ह्यूमन बीइंग हूं सर मैं. आप जैसे बड़े लोगों के सामने मैं कुछ कर नहीं सकता हूं. क्या बोला है सर? ओहो, बोला सर. इधर देखो, हीट ट्रांसफर टू द, देखो सर इस क्वेश्चन में ही आस्क व्हाट इज द नेट हीट ट्रांसफर टू रिजर्वायर एट 47. दिस मच हीट इज this work plus this is rejected to 47, and after developing output from this input, this much is rejected, this is rejected to 47, this is added to 47, this is added, total added is this plus this. Is it clear? चलो कोई बात नहीं सर. नेक्स्ट मस्त क्वेश्चन है सर. कैन यू सी दिस क्वेश्चन? चलो नेक्स्ट क्वेश्चन. I don't mind sir, I don't mind. मुझे कोई क्या बोला है? In current question. अच्छा, you want this question? अच्छा अच्छा अच्छा. I have not gone through the question. देखते हैं सर. I have not gone through the question. देखो, 1 kg of air as an ideal gas executes a Carnot power cycle having thermal efficiency of 50%. Okay. Can you write Carnot cycle, dear students? देखो, sorry, can you draw Carnot power cycle? देखो इधर देखो. चलो, it will be easy for me to represent on TS diagram. चलो, this is 1, this is 2, this is 3, and this is 4. And you know very well, in 1 to 2 there is a heat supply. And in 3 to 4 there is a heat rejection. ठीक है सर. And 1 to 2 is isothermal expansion or isothermal heat supply. And can I write T3 is equal to, देखो यहाँ पे लिखता हूँ सर. ये अच्छा क्वेश्चन है सर. This is a good question. We need to do it सर. हम लोग करना चाहिए. इधर देखो सर. कोई टेंशन नहीं है सर. 1, 2, 3, 4. कोई टेंशन नहीं है सर. देखो, can I write T1 is equal to T2? This is isothermal expansion or in this heat is supplied. ठीक है. This is isothermal rejection. कोई बात नहीं सर. And can I write T1 is equal to T2 is equal to T higher? इधर देखो, T1 T2 is higher temperature. T3 is equal to T4 is equal to lower temperature because it is isothermal heat rejection. ध्यान से सुनो सर. Now, क्या बोला है सर? The efficiency is given as 50% sir. The efficiency is given as 50%. Okay, कोई बात नहीं सर. It is 0.5. Now, the heat transfer during isothermal expansion is, अरे अल्लाह 0 दिया है. गलत है. शायद वो 50 है. मैं बताता हूं सर. एक सेकंड. हाँ, दिस इज गिवन एज 50 सर. माफी चाहता हूं, यहाँ पे मिस प्रिंट हुआ सर. 50 किलो जूल. तो हीट ट्रांसफर इन 1 to 2 is 50 किलो जूल. बहुत बढ़िया. It is 50. At the end of expansion, देखो, this is expansion. At the end of isothermal expansion, this is isothermal expansion. The pressure is 574. The pressure after isothermal expansion is 574 kilopascal. And the volume is also given at the end of expansion. At the end of expansion, कितना दिया? Volume at 2 is 3 meter cube. ठीक है सर. Is it 3? एक बार मैं चेक कर लेता हूँ सर. No, it is 0.3. It is 0.3. ठीक है सर. और क्या बोला है? Okay. Which of the following statements are true? कैसे करें सर? ये थोड़ा मुश्किल लग रहा है सर मुझे. ये थोड़ा मुश्किल लग रहा है सर. कैसे करें? मुश्किल लग रहा है सर, कैसे करें? मैं बताता हूं, सुनो केयरफुली. In an isothermal process, and moreover, it is an ideal gas. For an ideal gas, internal energy is a function of temperature. So during isothermal process, as the temperature is constant, the internal energy is constant. When internal energy is constant, the change in temperature is zero. So can I write d dash q is du plus d dash u? Yes. So for an isothermal process, heat transfer is also equal to what transfer? Yes sir. Yes sir. So देखो, अब देखो, heat transfer in 1 to 2 is also equal to 1 transfer in 1 to 2, and that is given as 50. क्या कोई isothermal का वर्क दे सकते सर? मैं देता हूं. Either P1 V1 or P2 V2 ln V final by V initial. क्या ये सही है गलत है सर? क्या ये सही है गलत है सर? Isothermal वर्क मैं बताया था. क्या either I can write P1 V1 or P2 V2. For isothermal P1 V1 P2 V2 are same. तो P1 V1 or P2 V2. Isothermal work is given by PV ln V2 by V1. ठीक है सर. What is the work given? 50 दिया है सर. ठीक है सर. P2. What is P2? 574. And what is V2? 0.3 ln V2 by V1. तो यहाँ से everything is known. I'll get the ratio V2 and V1. देखो ये बात. V2 by V1 is equal to, I'll get the ratio as 1.337. अब एक बात. Already V2 is given. V2 is given as 0.3. Can I calculate V1? Yes sir. V1 is equal to anyone. V1 is equal to calculate करो. V2 by 1.337. Correct sir. तो V1 is equal to V2 is 0.3 by 1.337. कितना आ रहा है सर V1? Anyone? What is the value of V1? बोलो रे. 0.2244. Now you may be wondering, सर ये क्या कर रहा है सर आप? मैं पूछ रहा हूं. देखो, why did you calculate V1? बोलो, why did you calculate V1? अब मैं बताता हूं. देखो, आपको टेम्परेचर चाहिए. सुनो केयरफुली, प्लीज डोंट वरी. नाउ एक सेकंड रुको. यहां पे P2 is given, V2 is given, mass is also given. Can I calculate T2 sir? It is an ideal gas. देखो, इधर देखो. P2 V2 is equal to mRT2. ठीक है सर. P2 is already given. अब मैं next rate जाऊंगा, नहीं जाऊंगा. P2 is 574. V2 is 0.3. एक बार देखो. V2 कितना है सर? V2 is 0.3. Excellent. V2 is 0.3. ठीक है. Is equal to mass is given as 1. For air, R is 0.287 and it is T2. Can you tell me the value of T2? Anyone with T2? Anyone with T2? अरे बोलो रे, T2 का वैल्यू दीजिए बच्चे. T2 का वैल्यू राहुल, T2 का वैल्यू आप नहीं दे रहे सर. बोलो सर, T2 का वैल्यू कुछ तो बोलो रे. 600. माया किस करेक्ट? 600. आप बताइए सर, क्या ये T2 हायर टेम्परेचर है या लोअर सर? देखो T2 और T1 it is the higher temperature. Can I calculate lower? Yes, it is a Carnot cycle, and you know the efficiency is also given as 50%. So what is the efficiency of Carnot cycle? The efficiency of Carnot cycle is 1 minus T lower by T higher. Efficiency is 50%. 1 minus the lower temperature I don't know, but T2 is also higher temperature. कैसे? इधर देखो. T2 is also higher temperature. So therefore now higher is 600. Excellent sir. So can you give me the value of T lower sir? 300 Kelvin. Wonderful sir. Lower temperature आ गया. अभी क्या पूछा है सर? एक बार देखो. अभी क्या पूछा है सर? The minimum temperature of the lower is 300. बहुत बढ़िया. And the maximum temperature is 327. Is it correct? We got, देखो, be careful sirs. We got the lower temperature. सुनो, the lower temperature is 300 Kelvin and the higher temperature is 600 Kelvin. Can I convert this in terms of degree centigrade sir? Can I convert in terms of degree centigrade? बिल्कुल बढ़िया. तो is the first option correct or not? The maximum temperature of water cycle is 327. It is also correct, sir. It is also correct. And pressure and volume at the beginning of isothermal expansion पूछा है. Beginning of expansion means 1 Already we have calculated volume at 1. इधर देखो 0.2244. Already we have calculated volume. Now let us calculate the pressure. इधर देखो कैसे calculate करेंगे? P1 V1 is equal to mR T1. Already V1 is calculated 0.44 and mass is known, R is known T1. T1 का मतलब क्या है सर? 1 to 2 is isothermal. 1 to 2 is isothermal. Already T1 T2 is known. ये दोनों same है isothermal. Higher temperature is 600. तो T1 और T2 is isothermal 600. तो अगर आपको P1 चाहिए mR T1 by V1. So therefore M is 1, R is 0.27, T1 is also 600 by V1. What is V1? 0.22. What is V1 sir? कहाँ गया? 0.2244. कितना आ रहा है सर pressure? What is the pressure sir? What is the pressure sir? 768 है? Wonderful sir. 767 और 768 kilopascal आ रहा है. Oh my God. 768. कितना आ रहा है सर? Yes, it is correct. और एक बात पूछा है सर, वो क्या पूछा है सर? हाउ मच हीट इज सप्लाइड, नेटवर्क भी पूछा है सर. हाउ मच एफिशिएंसी इज इक्वल टू नेटवर्क बाय हीट सप्लाइड. ठीक है सर. हाउ मच हीट इज सप्लाइड, ऑलरेडी ही गिव इन 1 to 2 देयर इज अ हीट सप्लाइड. व्हाट इज द हीट सप्लाई गिवन? व्हाट इज द हीट सप्लाई गिवन? इट इज 50. इट इज 50. सो देयरफॉर बट कंफ्यूज हो गया सर वर्क इज 50 ना. फॉर 1 to 2 heat transfer work transfers are same. It is 1 to 2 work है, लेकिन यहाँ पे compression है सर. So there is a input. He is asking net work मतलब cycle work. So if you want net work, it will be calculated from efficiency. Already efficiency is 0.5 and net work I do not know and the heat supply is 50. तो net work आ जाएगा 25 किलोजूल. यहाँ पे भी 25 है सर, ये 25 बिल्कुल 25 है. So all options are correct. ये भी अच्छा क्वेश्चन था सर. प्लीज बताइए. Oh my God, who said B में क्या प्रॉब्लम है? B में क्या प्रॉब्लम है? The minimum temperature is 300. B में क्या प्रॉब्लम है सर? स्पार्टन. B में क्या प्रॉब्लम है सर? Any problem? Spartan? C is not matching. कहाँ पे सर? कहाँ पे? हो. It is 767. यहाँ पे मिसप्रिंट हुआ. 767, around 767. क्यों आया पता है सर? 0.22 लेके करेंगे तो 782 आएगा. 0.2244 लेंगे तो 767 आएगा. It is correct sir. It is correct. So rounding off में. It is matching. It will match sir. It will match because I have taken 0.2244, but if you take 0.22, देखो अगर आप 0.22 लेते तो ये आंसर आता है 782 क्वेश्चन. समझ गए? होप यू अंडरस्टूड. लेकिन एग्जाम में ऐसा नहीं होगा सर. एग्जाम में ऐसा नहीं होगा. डोंट वरी. नेक्स्ट. सब लोग शॉक हो गए. ये क्या हो रहा है? कुलकर्णी सर अभी ले रहे हैं. ये करो सर. दिस इज अ गुड क्वेश्चन सर. करो सर. देखते हैं आपका टैलेंट. आपका टैलेंट देखते हैं सर. दिस क्वेश्चन विल डू. दिस इज क्वेश्चन नंबर 12. In fact, we have not done 12 questions. We have done more. Come on. This is a wonderful question, sir. आपको मजा आएगा ये क्वेश्चन में. 3 real heat engines. Oh my God. Real heat engines are not reversible. Don't apply Carnot equation. Have same efficiency. ये catchword है. And are connected in series. The first engine absorbs 2400 of heat from a reservoir at 1250. And the third engine rejects its waste of 300 to the sink at 150. What is the output from each engine? ये question को important mark करना sir. This question is very important. Let me explain what is this question sir. Let me explain this question sir. Engine 1, work 1, Q2. And same is given to second engine 2, work 2. this is Q3 and same is given to engine 3. This is work 3 and this is Q4. There are 3 engines connected. Whatever the first one is rejecting, second is absorbing. Whatever the second is rejecting, the third is absorbing. And what is given in the question? एक बार देखना. The first engine absorbs 2400 at 1250. This temperature is given as 1250 and this is 2400. ठीक है sir. And the last one क्या बोला है? And the third one rejects 300 at 150. This temperature is 150 and this is rejecting 300 kilojoule. Must question है sir. This is rejecting 300 ना? 300 okay 150. What a question this is. अब आगे बढ़े सर. सब लोग जिंदा है सर? No. देखो सर. Can I write efficiency is equal to 1 minus heat rejection by heat supply? बिल्कुल लिख सकते सर. Now, for the first engine, this is rejection, this is supply. For the second engine, rejection supply. For the third engine, rejection supply. Okay. What is the efficiency of one? और एक बात है सर. इधर देखो. Can we write heat rejection by heat supply is equal to 1? I am not writing efficiencies in terms of temperatures because it is not a reversible. It is a real engine. ठीक है सर. So for the first one, can I write? For the first one, rejection is Q2, supply is Q1. This is 1 minus efficiency of 1. Second के लिए क्या लिखेंगे? Second के लिए rejection by supply. For second, rejection is Q3 and the supply is Q2. Second के लिए rejection supply and that is equal to 1 minus. This is the general equation. तो second के लिए, okay. Third के लिए rejection is Q4, supply is Q3 and that is equal to 1 minus efficiency of 3. Q2 is not given, Q3 is not given. ध्यान से सुनो सर, common sense use करना. Q1, Q4 are given, but somehow I should eliminate Q2, Q3. कैसे करेंगे? तीनों को multiply करना सर ये. Q2 by Q1 into Q3 by Q2 into Q4 by Q3 is equal to तीनों को multiply करना. But all efficiencies are same. So 1 minus theta, 1 because all efficiencies are 1 minus theta, it will be 1 minus theta का whole cube. ठीक है सर. तो Q3 कट गया, Q2 कट गया, तो Q4 by Q1 is equal to 1 minus efficiency का whole cube. What is Q4? It is 300. What is Q1? 2400. And that is equal to 1 minus efficiency का whole cube. So इसको क्या लिखेंगे सर? तो 1 by 8. तो 1 minus efficiency whole cube is equal to 1 by 8. तो 1 minus efficiency is equal to 1 by 2. देखो, can I write 8 as 1 by 2 का whole cube? Yes sir. तो cube root ले लेना. 1 minus efficiency is half. So efficiency is equal to half. So I got the efficiency. खत्म sir. I got the efficiency. Is it not a good question sir? Is it not? So हर एक का efficiency कितना है सर? 50%. इधर देखो. क्या मैं वर्क कैलकुलेट कर पाऊंगा? इधर देखो. अगर 50% efficiency है, ध्यान से सुनो. अगर what is the efficiency of one? 50% 0.5 is equal to output by input. That is W1 by 2400. So what is W1 sir? W1 is 1200. तो ये वर्क आ रहा है 1200. Out of 2400, if work is 1200, rejection is also 1200. If this is 1200 and इसका efficiency 50% है, अगर 50% है, input is 1200, तो output कितना आना चाहिए? 600. अगर 600 output है, rejection will be 600. तो अगर ये 600 है, तो ये कितना होगा सर? 300. तो ये कितना होगा? 600 minus 300 is 300. So if the input is 600, work is 300, half. Because efficiency is half. If the input is 1200, output is 600. If the input is 24, so what is the work of one? Work of 1 is 1200. Work of 2 is 600. And work of 3 is 300. 1200, 600, 300. 1200, 600, 300. 1200, 600, 300. What a question, sir. What a question. मस्त था ये. Yes or no, sir? Sir, आप कुछ तो बोलो, sir. कुछ तो बोलो, sir. चलो क्या करें सर, रोक दे? 2 आवर्स बहुत ज्यादा होता है, मुझे कोई दिक्कत नहीं सर। अब आप बताओ व्हाट टू डू। तो कल स्पेशल क्लास ले ले, फिर रात में, कल रात में स्पेशल क्लास ले ले। टुमारो आई विल कवर रिमेनिंग क्वेश्चंस इन स्पेशल क्लास। तो अनअकैडमी ऐप में देख लेना स्पेशल क्लास। विल इट बी ओके? ठीक है, बिकॉज टुमारो मॉर्निंग आई हैव क्लास। कंटिन्यू। वाह सर, करा दीजिए और ले लो। वाह 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 वाह, वी आर रेडी। ये हुई ना बात, वाह वाह, मस्त है। बच्चे हो तो ऐसा होना रे। ये करो, ये करो। मस्त स्टूडेंट्स है। टाइम का कंस्टेंट है बेटा, there's a टाइम कंस्टेंट। इस बार सॉम में ना जो रेगुलर प्लस में चल रहा है, आई हैव एडेड ऑल न्यू क्वेश्चंस। कल भी और परसों भी। बहुत बढ़िया सर, बहुत बढ़िया। ओ जय रेड्डी, क्या करे, टाइम नहीं है अभी। Shall we proceed? Take this question. देखो, you know my dear students, PTH are continuous functions. तो x is equal to p, y is equal to t, z is equal to h. सुनो carefully, sir. It's a good question, sir. Can I write this as dou x by dou y? Dou x by dou y at constant z, ठीक है, into dou y by dou z। बहुत बढ़िया। at constant, देखो x का मतलब p, into dou z by dou x कितना है, dou p, ठीक है सर। at constant y का मतलब t, and you know this is equal to -1। कूलली देखो सर, बहुत बढ़िया सर। You know my dear students, dH is equal to Cp dt. What is dH by dt, sir? It is Cp, but it is at constant pressure. तो इसको मैं लिखेगा dou H by dou T at constant pressure is Cp. What is Joule-Thomson quotient? The Joule-Thomson quotient is dou T by dou P at constant enthalpy. देखो dou P by dou T. What is dou P by dou T? क्या at constant enthalpy? Can I write this as 1 by Joule-Thomson quotient? क्या मैं इसको 1 by Joule-Thomson बिल्कुल लिखूंगा। और dou T by dou H, what is dou T by dou H? It is 1 by Cp। उल्टा, dou T by dou H, अरे यार, dou T by dou H is 1 by Cp, and that is into dou H by dou P at constant temperature is -1। He is asking what is dou H by dou P at constant temperature। क्या होगा सर? ये दोनों उधर जाएंगे, माइनस है, यहाँ पे माइनस है, म्यू सीपी उधर जाएगा, तो इट इज माइनस म्यू सीपी। वेयर इज दैट? ऑप्शन ए इज करेक्ट। मित्रों बोलो। बहुत बढ़िया सर। टेक्निकल एंड नॉन टेक्निकल जॉब अड्डा वाले ने सही आंसर दिया, बहुत बढ़िया। टेक्निकल नॉन टेक्निकल अड्डा को सलाम। अरे व्हाइट टाइगर साहब कहां गए रे? नेक्स्ट क्वेश्चन। तो एक काम करते हैं सर, क्या करते हैं, चलो 10 बजे तक लेके छोड़ देता हूं, है ना सर? देखो डर गए लोग, हो जाएगा मैक्सिमम। तनुज है, डर गया वो, तनुज तो डर गया है। देखो ये क्वेश्चन ले लो, तनुज है, डर गया वो, तनुज भाग गया। देखो प्लीज रीड दिस क्वेश्चन। मस्त क्वेश्चन है रे। तंजू भाग गए हो। रीड द नेक्स्ट क्वेश्चन। करो। दिख रहा है सर आपको? दिख रहा है सर? कैन यू सी द क्वेश्चन? मैं बताता हूं, मैं थोड़ा हाईलाइट करता हूं सर. दिस इज ए, this is B, this is cycle 1, this temperature is 300 and this temperature is 600, this is 600, this is 300, this is 600 and this is A and this is B. It is entropy and this is temperature, this is entropy and this temperature. He is asking efficiency. कैसे कैलकुलेट करेंगे सर? इधर देखो. Can you tell me what is this closed area representing? On TS diagram, the closed area is net heat transfer. The closed area is net heat transfer. But from first law of thermodynamics, net heat is also equal to net work. So therefore, this will give me net work. बहुत बढ़िया. तो closed area network देगा. तो क्या होगा? ये एरिया कैलकुलेट करो. क्लोज एरिया, ट्रायंगल एरिया, हाफ इनटू बेस, दैट इज b minus a into height. What is this height sir? 600 minus 300 is 300. तो नेटवर्क आ रहा है, इधर देखो सर, हाफ मतलब ये 150 होगा सर, हाफ है ना, into b minus a. ठीक है. Let us calculate network in this cycle also. इस साइकिल में भी कैलकुलेट करेंगे. This is giving me network. What will be the network closed area? Half into base. What is that base? B minus a. Into height. ये height कितना होगा सर? 600 minus 300 is 300. I repeat. Half into base into height. Triangle का area. Network यहाँ पे भी 150 into B minus a आ रहा है. यहाँ तक किसी को कोई समस्या नहीं. Can I say both efficiencies are same? मित्रों, can I say both efficiencies are same? गलत. Because efficiency not only depends on network, it also depends on heat supply. अब heat supply देखेंगे. इधर देखो सर, एक साइकिल दिया है, मैं बताऊंगा सर. One cycle is given like this. पहले वाला like this. Is it correct? ठीक है. This is given as A, B, 300. 600 करेक्ट ना? 300 600 ये भी करेक्ट. इधर देखो सर. Now, what is this process representing? It is entropy. So entropy is isentropic heat, reversible adiabatic. तो इसमें heat transfer zero है. Heat transfer is zero because it is reversible adiabatic. In this, entropy is decreasing. Entropy is decreasing. Entropy decrease means heat rejection. So in this, entropy is increasing. In this, entropy is increasing. इसमें entropy बढ़ रहा है. That means from this to this, let this be 1, 2, 3. So therefore, now in this, there is in this, देखो, entropy is increasing means there is a heat supply. So how to find out heat transfer? कुछ नहीं सर, process ले लेना. You take the process and project it. अगर आपको heat transfer चाहिए, इधर देखो, इस प्रोसेस को आप प्रोजेक्ट करो, इसको प्रोजेक्ट करो, ये एरिया कैलकुलेट करो. दैट विल गिव मी हीट सप्लाई फॉर वन. व्हाट इज द हीट? समझ में आ रहा है सर? सो इट इज अ ट्रेपेजियम. हाफ इनटू सम ऑफ द पैरेलल सेट्स. दिस इज 600, दिस इज 300, दिस इज 600, दिस 300. तो 600 plus 300 into area of trapezium, half into sum of the parallel sets into distance between them, b minus a. तो ये होगा b minus a. तो what is the heat supply sir? ये 900 by 2 is 450 into b minus a. So what is the efficiency of first cycle? Network is 150 into b minus a by heat supply is 450 into b minus a. So this is coming out to be 1/3 means 0.33. Similarly, let us calculate the heat supply in second cycle. What is that second cycle? ये ऐसा आ रहा है सर, इधर देखो, ऐसे ऐसे ऐसे. Is it correct? Yes, yes. Is it correct sir? Yes. This is 600 and this is 300. This is A and this is B. देखो, is it, what is this process? Constant entropy, reversible adiabatic, no heat transfer, no heat transfer. What is happening here? Entropy is increasing, तो heat supply होगा इसमें. What is happening here? Entropy is decreasing, heat rejection. So I want heat supply. So for heat supply, identify the process. For heat supply, identify the process. This is the process. And if you want the heat transfer, just project it. This will give me the heat supply. Anyone, what is the heat supply? It is length into it, that is 600 into B minus A. In both the cases, the network was same. Network output was same. Network by heat supply is 600 into B minus A. So this is gone. So 150 by 600 is 1 by 4. It is 0.25. So which one has more efficiency? Which one has more efficiency? एक बार बोलो. So efficiency of 1 is greater than efficiency of 2. Efficiency of 1 is greater than efficiency. I think B is correct. नहीं आ रहा है सर आपको? नहीं आ रहा है सर आपको? नहीं आ रहा है सर आपको? Is it correct? मैं आगे बढ़ सकता हूं मित्रों? बहुत बढ़िया चल रहा है सर. वंडरफुल. गो टू द नेक्स्ट. नहीं छोड़ेंगे सर आपको. नौकरी मिलनी है. रीड द क्वेश्चन. Come on, read the question. An insulated rigid tank. थोड़ा देर मैं इसको बंद कर दूंगा सर. ठीक है, आप लोग तैयार हैं ना? An insulated rigid tank. देखो rigid tank, can I say constant volume? Yes. Contains 0.9 kg of air at a pressure of 150 kilopascal and a temperature of 20 degree. मतलब 273 plus 20 is 293 Kelvin. A paddle wheel inside the tank is rotated by an external source until the temperature rises to 55. So 273 plus 55 ये कितना आएगा सर? 328 Kelvin. क्या ये सही है सर? Correct है. If the surrounding is at 20 degrees centigrade, 20 means 293 Kelvin. What is the exergy destroyed? मतलब क्या पूछ रहे हैं सर? Irreversibility. Exergy destroyed. Irreversibility. You know that irreversibility is equal to exergy destroyed is irreversibility T naught into entropy change of universe or entropy generation. Excellent. मैं क्लास में बताया था आपको. Because of work transfer, there is no entropy transfer. But because of heat transfer, there is a entropy transfer. ये सब बताया था मैं. देखो, it is insulated tank. Now I want the entropy change of universe, which is also equal to entropy generation. It will be entropy change of system plus entropy change of surroundings. Can you tell me what is the entropy change of surroundings? I taught very beautifully in my regular plus classes. Whenever the system is insulated, there is no energy interaction in the form of heat transfer to surroundings. So therefore, the surrounding entropy change is zero in adiabatic process. So if you want the entropy change of universe in this problem, if you want the entropy change of universe, it will be surrounding is zero, it will be equal to system only. सिर्फ system का calculate करो. Universe का मतलब यहाँ पे system plus surroundings, but surrounding is zero, therefore it is system. चलो यहाँ पे system ही आएगा. T naught is given, calculate करो. How do I calculate? The system is undergoing constant volume process. देखो सर, MCV देखो एक बार, MCV ln याद है आपको? T2 by T1 plus MR ln V2 by V1. Hope you remember this. I have given you 3 equations for ideal gas. क्या ये equation सही है सर? एक बार बताओ सब लोग. क्या ये equation सही है मित्रों? बोलो. तो ये तो 0 हो गया. मास दिया है क्या? 0.9. मास दिया है क्या सर? 0.9. ओके. 0.9. CV कितना है सर? 0.718 into ln T2 by T1. What is T2 by T1? What is T2 by T1? मयांक एक बार चेक कर लेना. मयांक एक बार चेक कर लेना. T2 by T1. Final temperature is 328. and the initial is 293. So what is the entropy change of system? What is the entropy change of system, sir? Anyone? 0.0729. मयांक एक बार फिर चेक करना. 0.0729. 0.0729. तो पुट करो यहाँ पे. तो irreversibility is T0 is 293. It should be given. Entropy change of universe is system plus surroundings. Surrounding is 0. System का कितना है सर? System का 0.0729. So how much is this? कितना आ रहा है सर? मयांक. Yes, 21.3 something आ रहा है. Around 22. मयांक कहां पे मिस्टेक हुआ? वेरी गुड. नेक्स्ट. क्या क्वेश्चन है सर ये? क्या क्वेश्चन है सर ये? प्लीज रीड दिस क्वेश्चन. खाना खाए, एक 10 मिनट खाना खा के आएंगे फिर. What do you say? Shall we take a break of 10 minutes? Shall we take a break of 10 minutes? 10 मिनट या 15 मिनट? बोलो. मुझे भी भूख लग रहा है. राहुल साहब नो बोलता है, एस बोलता. तो एज पर माई वॉच इट इज 9:20. तो वी आर मीटिंग एट 9:35. वी आर मीटिंग एट 9:35. इज इट ओके? वी आर मीटिंग एट 9:35. अरे यार 20 मिनट मत लेना सर, विल कंप्लीट प्लीज. अच्छे अच्छे क्वेश्चंस है. ठीक है, चलो ब्रेक टाइम स्टार्ट्स नाउ. ठीक है, ब्रेक टाइम स्टार्ट्स नाउ. आगे मित्रों, चलिए चलिए वेरी गुड। आगे हमारे बच्चे, बहुत बढ़िया रे, बहुत बढ़िया रे। यस 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 यस। हाँ जी, करेंगे जितना हो सके उतने क्वेश्चंस विल ट्राई टू कंप्लीट। हाउ मेनी क्वेश्चन डिड वी सॉल्व? हाँ, ये वाला इंपॉर्टेंट था। चलो चलो। अरिंदम 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 अरिंदम। Let's see this question. It's a good question. It's a good question, sir. So I'm starting. Dear students, I'm starting. So can you see? दिख रहा है ना? Okay, okay. Come on, come on. Yes, sir. Ready. बहुत बढ़िया. A system executes a power cycle while receiving 750 kilojoule by heat transfer at a temperature of 500. Oh, it's not 500. It is 1500, I think. Let me check. 1500. Misprint हुआ यहाँ पे. 1500. हाँ. एक second. Let me erase this. Temperature of 1500 and discharging 100 kilojoule by heat transfer at a temperature of 500. ठीक है. Another heat transfer in the system occurs at temperature of 1000. ठीक है. Shown. use Clausius inequality. Cyclic integral of derivative is minus sigma cycle. Okay, and the sigma cycle is fine. I'll tell you what is this question. Let me explain what this question is exactly. This power cycle, it is receiving 750 at 1500 Kelvin. Okay. It is developing some network of the cycle. Okay. It is rejecting how much, sir? 1000 at a temperature of 500 Kelvin. Okay, sir. This is also rejecting Q3 at 1000 Kelvin. Please listen carefully. This power cycle is receiving only from one. This is going out, this is going out. Look at carefully. If you take the power cycle as our system, it is receiving 750. It is rejecting Q3. It is rejecting Q2. So what is the total supply? There is only one supply, that is 750. What is the total rejection, sir? This is going out. ये बाहर जा रहा है 1000. Plus this is also going out. This is also going out. This is also leaving. This is also leaving. It is Q3. And he is asking, what is the efficiency of the cycle? Efficiency is equal to 1 minus rejection by supply. I have no problem with supply. Supply is 750, but I have a problem with rejection. Therefore, I need to find Q3. Can you tell me how to find Q3? इधर देखो सर, Clausius inequality. इधर देखो. Actually, ऐसा दिया सर, वो देखो. It is absorbing. कितना absorb कर रहा है सर? 750 at 500, 1500. At 1500. It is rejecting. It is also rejecting. Now I say दिखाऊंगा सर. This is the network. What is this, sir? This is given as 1000. My diagram को modify कर रहा हूँ सर. My diagram को 1000 at 500 Kelvin. This is not given Q3, but the temperature at which Q3 is rejected is 1000. देखो सर, 1000 दिया है सर. This temperature is 1000. And he is asking efficiency. कैसे calculate करेंगे? देखो. Clausius inequality says cyclic integral of d dash q by t is less than or equal to 0. Less than or equal to 0. When it is equal to 0, the cycle is reversible. When it is less than 0 का मतलब negative. It is irreversible. Add करना सर. ये अंदर आ रहा है. तो 750 by 1500. It is plus. It is entering plus. This is देखो एक बार बहुत carefully देखो. Work has nothing to do in Clausius inequality. Entering plus. It is leaving. Minus Q3 by 1000. This is also leaving. ये भी जा रहा है. Minus 1000 by 500. And this is given as minus sigma. दिया है सर. This is given as cyclic integral is less than or equal to 0. तो ये less than मतलब negative. ये value दे रखा है. कितना दिया है सर? Minus sigma. But sigma is 0.1. Sigma is 0.1. So this is minus sigma means minus 0.1. ये दिया है सर. Minus sigma means minus 0.1. क्या आपको समझ में आया सर? Let me check sir. 750 by this minus Q3 by this. ये 100 दिया, 1000 दिया सर. ये 1000 दिया, 100 दिया. एक बार चेक करता हूँ. 1000 by 100 दिया है सर. ये 100. हाँ. एक बार चेक करो. 100 500. ये 100 है सर. ये 100 है. 1000 नहीं है. ये 100 है. This is given as 100. This is given as 100. ये नहीं है. Correct. This is given as 100. 100. 750 by 1500. Q3 by 1000. ये सही है. तो anyone with Q3. Yes, anyone with Q3. Q3. So if you are calculating from the ये नहीं है sir. It is 100, not 1000. I'm sorry. कितना आ रहा है sir? Q3 का वैल्यू कितना आ रहा है sir? Q3. This is given. Cyclic interrupt. Yes, 400. Who got 400? Yes, absolutely correct. So what is the total rejection? This is rejection, this is rejection. It is Q2 plus Q3, and that is कितना आ रहा है सर? It is 400 plus 100. So the total rejection is 500. Total rejection is 500, and the total supply is 750. So efficiency is 1 minus rejection is 500 by supply is 750. 1 minus rejection by supply. So how much is the efficiency, sir? कितना आ रहा है सर efficiency? 0.33 is correct. Excellent students of India. ये भी अच्छा क्वेश्चन था सर. 33%. 33% is correct. ये करो. Please read this question. Come on. 1/3 is correct. Correct. Take this question. Using Clausius-Clapeyron equation, the enthalpy of vaporization at 200 Kelvin. So can I write 200 centigrade, convert in Kelvin. 200 plus 273 is 473 Kelvin. The specific volume Vg is given as 0.1274, and the specific volume of saturated liquid is given as 0.001157, and dP by dt is given, sir. What is dP by dt given? 32 kilopascal per Kelvin. He is asking enthalpy. You know Clausius-Clapeyron equation. dP by dt is equal to enthalpy of vaporization by T into Vg minus Vf. Do you remember this equation, sir? Do you remember this equation? Mic नहीं लगा, भूल गया देखो. Okay, so dP by dt is given as 32. यहाँ पे दिया है 32. LH पूछ रहा है सर, कोई दिक्कत नहीं. If this is in kilopascal, this will be in kilojoule per kg. By temperature is 473 into Vg minus Vf. What is Vg? 0.1274 minus Vf is 0.00157. तो ये आएगा आपका LH. कितना आ रहा है सर? How much is LH? 1910. Absolutely correct. Yes. Go to the next question. ये करो. Come on. Come on. Yes. Given for water at 190, the saturation pressure is 8 second. T1 is equal to 190. And what is the saturation pressure corresponding to 190? The saturation pressure is 12.54. लेकिन ये बार में दिया है. But the answer is asked in kilojoule per kg. तो whenever you want kilojoule, bar को kilopascal में convert करना, तो I am multiplying with 100. See, if you want to convert bar into kilopascal, I have to multiply. But why are you converting? Because this pressure is in bar. The answer is asked in kilojoule per kg. So therefore, multiply with 100. This will be in kilopascal. And another temperature is given at 210. What is the saturation temperature? What is the saturation temperature? At 210, so the saturation pressure is 19.06. Again, it is in bar. उसको kilopascal में convert करना. ठीक है सर. Okay. अब सवाल ये है. At 200 degrees centigrade, देखो. At 200 degrees centigrade, the specific volume of saturated liquid is 1.1565 into 10 k power minus 3. Okay, the specific volume of vapor is given, saturated vapor, 0.1274. Okay, that is also given. Using Clapeyron equation, the enthalpy of vaporization at 200 degrees centigrade. Can I write this 200 degree centigrade as 473 Kelvin? Yes sir. अब देखो, in previous question dp by dt was given, तो इसमें हम dp by dt कैलकुलेट करेंगे. What is dp by dt sir? Anyone? तो P2 minus P1 by T2 minus T1. Whenever it is difference in temperature, it doesn't matter whether it is in Kelvin or degree centigrade. So dp by dt is equal to P2 minus P1. What is P2 minus P1? 19.06 minus 12.54 into 10 power 2, that is 100 by dt, temperature difference. अगर ये P2 minus P1 है, P2 minus P1, T2 minus T1, whenever it is difference in temperature, फर्क नहीं पड़ेगा Kelvin और degree centigrade. 210 minus 190 is 20. यहां से dp by dt आ जाएगा. तो my equation is dp by dt is equal to latent heat by T into Vg minus Vf. अब देखना किस टेम्परेचर पे पूछा है. He asked at 473. तो already dp by dt is known, यहां पुट करना. Already this is known. 19.06 minus 12.54 by, इसको 20 लिखूंगा सर, 210 minus 180 into 100. That should be equal to latent heat, I don't know, and this is 473 Vg minus Vf. Vg is 0.1274 minus Vf. What is Vf sir? 1.1565 into 10 power minus 3. तो ये सब पता है. I get LH. कितना है सर LH? No. There is a misprint. It is meter cube per kg only, sir. There is a misprint. It is meter cube per kg only, sir. It is meter cube per kg only, sir. Sorry. How much is the answer? 1940. ये into 100 नहीं दिख रहा है यहाँ पे आपको. into 100 नहीं दिख रहा. तो ये आएगा आपको 1946 is the right answer. 1946 आ रहा है सर. Correct. Go to the next question. ये अच्छा क्वेश्चन है सर. First question. Good. Read the question. And you should remember TDS equations. ये अच्छा क्वेश्चन है सर. देखो, a gas has an equation P into V minus B is equal to RT, where B is a positive constant. During throttling, what will happen to the temperature of gas? This is a good question, sir. कैसे? देखो एक बार. I want if you find out Joule-Thomson coefficient, if the Joule-Thomson coefficient is 0, the temperature remains constant during throttling. If the Joule-Thomson coefficient is positive, temperature decreases during throttling. If the Joule-Thomson coefficient is negative, the temperature increases. कैसे? एक बार रिफ्रेश कर लेंगे सर. Let us refresh once. देखो, इसमें स्लोप क्या है सर? म्यू इज पॉजिटिव. ऑल दिस आई हैड एक्सप्लेन्ड इन क्लास. इसमें म्यू क्या है सर? नेगेटिव है. थ्रॉटलिंग में हमेशा प्रेशर डिक्रीज होता है. इधर देखो, इफ दिस द इनिशियल पॉइंट एंड इफ दिस द फाइनल पॉइंट, थ्रॉटलिंग प्रेशर इज डिक्रीजिंग. जब प्रेशर डिक्रीज हो रहा है तो टेम्परेचर बढ़ रहा है. तो अगर आपको म्यू का वैल्यू नेगेटिव आता है तो टेम्परेचर विल इंक्रीज ड्यूरिंग थ्रॉटलिंग. अगर म्यू का वैल्यू पॉजिटिव आता है, टेम्परेचर विल डिक्रीज ड्यूरिंग थ्रॉटलिंग. ऑल दिस आई हैड एक्सप्लेन्ड इन माय रेगुलर क्लासेस. क्या ये समझ में आया सर? सब क्लास में बताया था. चलो हम जूल-थॉमसन कोएफिशिएंट को कैलकुलेट करेंगे. वी नो दैट TDS is equal to DH minus VDP. ठीक है सर. Already you know the second TDS equation. देखो, ये याद रखना है सर. TDS का देखो, CPDT minus T into two TDS equations you are supposed to remember. Already I have derived this in class. ये मैं कुछ नहीं कर रहा हूँ. TDS is equal to DH minus VDP. I'm taking second TDS. I'm just substituting TDS value as CP dt minus T into this. In this equation is DH minus VDP. ठीक है सर. अब क्या करेंगे? Now सुनो. इसको थोड़ा हटा देंगे सर. Let me erase this. Let me erase. This is a good question and you should pay attention to this. देखो सुनो. तो अब हम पुट करेंगे. तो क्या लिख रहा है सर? DH is equal, कहाँ गया है वो? ठीक है. Or DH can be written as anyone. DH. You bring VDP to this side. It will be CP dt minus T into dou V by dou T P dP. ठीक है. I want DH ना. DH चाहिए तो ये इधर लाना. CP dt इधर आया तो माइनस कॉमन लिए तो माइनस V. I'm just rearranging sir. टेंशन में मत आना. Is it correct or not? इस इक्वेशन को सिर्फ रीअरेंज किया सर. DH is equal to I brought VDP this side माइनस कॉमन लिए. सही है ना? बिल्कुल सही है. Now for throttling TH is 0. ये 0 होगा. 0 is equal to CP dt minus T into dou V by dou T at constant pressure minus V into dP. ठीक है सर. तो CP dt is equal to T into dou V by dou T at constant pressure minus V into dP. चलो ठीक है. dou T by dou P is equal to dt by dP. ये CP को इधर लेना 1 by CP into T into dou V by dou T at constant pressure minus V. आप लोगों को ये याद रखना है सर. जूल थॉमसन क्वेश्चन. This is Joule Thomson question. Why? Actually it is a partial derivative because it is evaluated at constant enthalpy. ये आप enthalpy constant लिए. Whenever one property is kept constant, जब भी आप किसी को constant करके differentiate करेंगे partial हो जाएगा. तो ये partial है सर. So therefore now I write dou T by dou P and this you have evaluated at constant enthalpy. देखो dou T by dou P, इसको dou T by dou P लिखूंगा. क्यों सर? क्योंकि this is evaluated at constant enthalpy. So I write this as H at constant enthalpy is equal to, ये value क्या है सर? This is evaluated at constant enthalpy. ये enthalpy को constant किए 1 by CP into T into dou V by dou T, T into dou V by dou T minus V. एक बार चेक करना. ये सब मैं क्लास में डिराइव किया सर. All these I had derived dou V by dou T P minus V. Yes, is it correct? ये सब मैं डिराइव किया सर. Is it clear? देखो सर, I have to explain in all languages. So if I explain in Hindi, मुझे कोई दिक्कत नहीं है सर हिंदी में समझाने के लिए, लेकिन अंग्रेजी वाले भी आते हैं. अब क्या करूं मैं? सबको तो साथ में चलना, लेके चलना है. सबका साथ सबका विकास है ना. चलो कोई बात नहीं. सुनो सर, P into V minus B is equal to RT दे रखा है. तो क्या मैं इसको ऐसे लिखूंगा सर? is equal to RT by P. बिल्कुल लिखेंगे सर. ये P को you can take. और V is equal to RT by P plus B. Let us calculate dou V by dou T P. You differentiate V with respect to T by keeping pressure constant. तो dou V by dou T at constant pressure. तो क्या होगा? R is constant. You are evaluating at constant pressure. तो T is also constant. What is the differentiation of T? You are differentiating V with T. T का differentiation क्या है? 1 है. And B is constant तो 0 होगा. तो dou V by dou T P is equal to R by P. ठीक है सर. So mu लिखेंगे इसको. This is nothing but Joule Thomson question mu. This is Joule Thomson question. Mu is equal to 1 by Cp into T into dou V by dou Tp. What is dou V by dou Tp? R by P. ठीक है. dou V minus V. ठीक है सर. Excellent sir. Now mu is written as, look at carefully, 1 by Cp into RT by P minus V. What is RT by P minus V? इधर आइए, RT by P minus V, you take minus to that side, that is equal to minus V. So this value is anyone, ये value आ रहा minus B. So Joule-Thomson quotient is minus B by Cv. Same question can be asked like this. The Joule-Thomson quotient for this gas is, ये आ गया. अब देखो, Cp is always positive. What about B? What about B? वो clearly बोला B is a positive constant. B is a positive constant. जब B positive है, Cp positive है, तो already यहाँ पे negative अटैच है, तो mu का value is coming out to be negative. Joule-Thomson quotient का value, ये positive है, Cp is also positive, negative. What does Joule-Thomson quotient negative mean? Look at sirs. What does Joule-Thomson quotient negative mean? Look at. Please observe. Here, from the inversion point, यहाँ से mu is negative. Means throttling always occurs in the direction of decreasing pressure. तो pressure decrease होना चाहिए. इधर देखो, throttling इस direction में होता है. तो mu इस line पे mu, इस curve पे mu negative है. हमें भी negative आया. तो temperature क्या हुआ सर? T1. यहाँ पे T2. Temperature क्या हुआ? When mu is negative, Joule-Thomson quotient is negative. The temperature is increasing. T2 से T2 ऊपर जा रहा है. So temperature is increasing. So therefore the temperature increases. The answer is, in this case, the temperature increases. Temperature increases. कहाँ है? C is the right answer. Is it clear मित्रों? सर कुछ तो बोल रहे. राहुल कूलिंग बोल रहा है. यहाँ Joule-Thomson quotient नेगेटिव आया सर. When it is negative, it is a heating region. क्या हो रहा सर आपको? क्या हो रहा है सर आपको? हाँ जी, ये बहुत इंपॉर्टेंट है. मस्त वाला क्वेश्चन. This is also a good question, sirs. This is also a good question. Okay. Let me read the question. An air conditioning system involves mixing of, यहाँ पे actually insulation दिया सर ये. There is a cold air entering, there is a hot air entering. ठीक है. Cold air is entering at 7 degrees centigrade and the hot air is entering at 34 degrees centigrade. ठीक है सर. है सब लोग जिंदा है सब लोग. Okay. Cold air is entering at 7, the hot air is entering at 34. After mixing, इसको हम ऐसे ले लेंगे सर. इसको C रखेंगे मतलब कोल्ड, इसको H रखेंगे मतलब हॉट. मिक्स होके इसको 1 ले लेंगे, इसको 1 ले लेंगे और इसको 2 ले लेंगे. ठीक है. एंड दिस एग्जिट टेम्परेचर, प्लीज लिसन केयरफुली. व्हाट इज 1? इनलेट टू द रूम. व्हाट इज 2? एक्सिट फ्रॉम द रूम. लेट मी रिपीट सर. Cold air at 7 degrees centigrade is entering, hot air at 34 is entering. These two mix and it is adiabatic mixing. Oh, word miss हुआ. It is adiabatic mixing. Mix होके वो रूम में आ रहा है सर. ये एयर रूम में आ रहा है. इन रूम में आने के बाद रूम से कुछ हीट ट्रांसफर दिया है सर. एंड फाइनल टेम्परेचर इज दिस. ये एडियाबैटिक मिक्सिंग दिया है सर. एक्चुअली फिगर में ये मिक्सिंग है, ये इंसुलेटिंग चेंबर है. क्या पूछा है सर? द मिक्सचर टेम्परेचर एट द इनलेट टू द रूम इज, ये पूछा है. द मास फ्लो रेट ऑफ द मिक्सचर एट द इनलेट टू द रूम इज, ये पूछा है. यहां का मास फ्लो रेट. द रेट ऑफ हीट गेन इनटू द रूम, रूम में कितना हीट आ रहा है. The mixing temperature at inlet of the room. ठीक है सर, करेंगे, कोई चिंता मत करो सर. Please listen carefully. It's a very good question I am doing. It's a steady flow. माय डियर स्टूडेंट्स, स्टडी फ्लो में क्या होगा, h1 plus c1 square by 2 plus z1 g plus q, याद है सर आपको? whenever the kinetic potentials are not given, क्या बचता है? सिर्फ एंथैल्पी, हीट ट्रांसफर, वर्क ट्रांसफर बचता है। मिक्सिंग में will you get any work? क्या मिक्सिंग में आपको कोई वर्क मिलता है? बिल्कुल नहीं मिलता है सर, बिल्कुल नहीं मिलता है। एंड दिस इज एडियाबैटिक मिक्सिंग। देखो, आई विल राइट दिस एज M1H1, ऐसे प्रॉब्लम्स करवाया था स्टडी फ्लो। M1H1 कोल्ड कोल्ड हॉट, देखो MCHC M1H1 प्लस MHCH, अरे मैं पागल हो गया आपकी तरह, देखो वेट सर, वेट, अरे यार M1H1 प्लस M2H2, आई रिपीट सर, यहां पे C का मतलब 1, H का मतलब 2, M1H1 प्लस M2H2 इज इक्वल टू, यहां पे 1 पे आ रहा है तो M1H1। एक्सीलेंट सर। एनी प्रॉब्लम सर? इज देयर एनी डिफिकल्टी? लेट मी रिपीट, M1H1 प्लस M2H2, ये इक्वेशन कहां से आया? आई हैड एक्सप्लेन्ड वेरी क्लियरली इन माय थर्मोडायनेमिक्स। M1H1 प्लस M2H2, 1 का मतलब कूल, M1H1 प्लस M2H2 इज इक्वल टू M3H3, ठीक है सर। Here it is given the mass flow rate of hot to mass flow rate of cold is, somewhere it is given, कहां गया रे वो? Where is it given? The mass flow rate of hot to cold is 1.6, it is 1.6, don't worry sir। इधर देखो सर, MC HC CPTC आप केल्विन में भी ले सकते हैं या डिग्री सेंटीग्रेड में भी ले सकते हैं, बिकॉज द रेफरेंस इज 0 डिग्री सेंटीग्रेड। कोई बात नहीं, चलो केल्विन में ही ले लेंगे, ठीक है। दोबारा बता रहा हूं, क्या ये इक्वेशन समझ, दिस इज एंटरिंग, दिस इज एंटरिंग, शुड बी इक्वल टू दिस, ठीक है। M1H1 प्लस M2H3 इज M3H3, दिस प्लस दिस इज इक्वल टू दिस, ठीक है। MC HC CP, एयर तो एयर के लिए तो Cp सेम है, हॉट और कोल्ड के लिए Cp 1.005 दिया, Cp हॉट और कोल्ड के लिए सेम दिया है। एंथैल्पी कैन बी रिटन एज Cpt, ठीक है, प्लस Mh, व्हाट इज Mh सर? 1.6 Mh, 1.6 Mc, Mh को 1.6 Mc लिखेंगे into Ch, Cpth, very good, is equal to M1। Can anyone tell what is M1? This mass plus this mass should be equal to this mass, तो MC plus MH is equal to M1। This mass plus this mass is this mass, तो MH is already given as 1.6 MC, this is 1.6 MC, this is 1.6 MC plus 1.6 MC is M1, which is 2.6 MC, so this is 2.6 MC, okay। H1 is CpT1, तो CP गया, तो we are left with MCTC plus 1.6 MCTH is equal to 2.6 MC into T1। MC is gone, तो TC plus 1.6 TH is equal to 2.6 T1। Excellent sir, बहुत बढ़िया। तो is it correct sir? Is it correct my dear students? TC कितना दिया? आप केल्विन में भी ले लो या सेंटीग्रेड में ले लो, कोई फर्क नहीं पड़ेगा। चलो केल्विन में ले लो, 273 plus 7 TC, 273 plus 7 is 280 plus 1.6 TH, what is hot temperature? 273 plus 34, 273 plus 34 कितना आ रहा है सर? 273 plus 34 308, नहीं आ रहा सर, 273 is it correct? 2737 307, ठीक है, is equal to 2.6 into T1, I don't know T1, all are in Kelvin, Kelvin में आएगा, कितना आएगा एक बार बताओ, कितना आएगा एक बार बताओ, कैलकुलेशन मिस्टेक तो नहीं किया सर? -296 कुछ आ रहा है सर, -273 करो, 23.6 आ रहा है सर, मतलब 296 केल्विन इज आल्सो करेक्ट, 23 डिग्री सेंटीग्रेड इज आल्सो करेक्ट। क्या ये सही है सर? अरे कुछ तो बोलो रे। वंडरफुल सर, बिल्कुल बढ़िया, बिल्कुल बढ़िया, ये आ गया। वंडरफुल। तो आई नो दिस टेम्परेचर। अब सवाल ये है, हाउ मच मास इज एंटरिंग, क्या बता सकते सर, कितना मास आ रहा है सर? mc प्लस mh, m1, तो that m1 is nothing but mc plus 1.6 mc, because mh is 1.6 mc, mc plus 1.6, तो इसको लिखेंगे 2.6 mc, नहीं आ रहा है सर, 2.6 mc। now my dear students, अब आप बताओ, the same air is entering and the same air is leaving, so it is a steady flow. For steady flow, whatever the mass is entering, the same mass is leaving. Can I say mass here is equal to mass here? Exactly sir, कोई प्रॉब्लम नहीं है। इसको थोड़ा मैं हटा दूंगा सर, थोड़े लोगों को समझ में नहीं आ रहा है सर। Some people are not following. Is it correct my dear students? Is it correct? एक बार देखना। So ये मास आ रहा है, तो अब बताओ सर, this is entering, ध्यान से सुनो, steady flow एनर्जी इक्वेशन अप्लाई करो, m1h1 plus q is equal to m2h2, इसको 2 ले लेंगे, बिकॉज इस रूम से कोई वर्क नहीं मिल रहा है। स्टेडी फ्लो एनर्जी इक्वेशन, एनर्जी एंटरिंग दिस प्लस दिस शुड बी इक्वल टू दिस, m1h1 plus q is equal to m2h2, he is asking q, so q will be equal to m2h2 minus m1h1, excellent sir। बट m1 m2 is same, m1 m2 दोनों बराबर है, m1 m2 दोनों बराबर है, so therefore m1 को बाहर ले लो, h2 minus h1, excellent sir, और m1 into cp into t2 minus t1 sir, t2 minus t1, ठीक है सर? नहीं आ रहा है सर आपको? नहीं आ रहा है सर? आई रिपीट सर, एंथैल्पी कैन बी रिटन एज cpt, m1 m2 बराबर है तो बाहर लेना, बिकॉज जो मास आ रहा है वही जा रहा है, एट 1 and 2 मास इज सेम, सो मास को बाहर लीजिए, ठीक है। बट व्हाट इज m1? m1 इज 2.6 mc, लेकिन mc पता नहीं है सर, कैसे कैलकुलेट करेंगे? बहुत बढ़िया, द कोल्ड एयर इज एंटरिंग एट 7 डिग्री एंड 105 at the rate of 0.55 meter cube per second, इसका मतलब volume flow rate of cold air is given, the pressure of cold air is given, the temperature is given, PV is equal to MRT, लेकिन volume is in meter cube per second, तो you will not get mass in kg, but you get kg per second। चलो कैलकुलेट करो, कौन सा दिया है? ये सब cold के दिया है, इधर देखो, cold air enters at 7, 105 pressure and 0.5, तो cold air के लिए मैं अप्लाई कर रहा हूं PV is equal to MRT, तो M is equal to PV by RT, ये cold air का है सर, this will give me cold air, pressure is 105, what is the volume? 0.55, air 0.287, at what temperature the cold air is entering? 7 degree, यहाँ का पूरा कंडीशन दिया, मास फ्लो रेट कोल्ड का कैलकुलेट करो, प्रेशर इज गिवन, कोल्ड एयर का प्रेशर दिया, कोल्ड एयर का वॉल्यूम दिया, कोल्ड एयर का टेंपरेचर दिया, मास फ्लो रेट कैलकुलेट करो इनटू टेंपरेचर, 273 plus 7 is 280, so I will get the mass flow rate of cold air। Anyone, what is the mass flow rate of cold air? कोई बताओ रे, what is the mass flow rate of cold air? Cold air 0.7186, mass flow rate of cold air is 0.7186, but मुझे m1 चाहिए। What is m1? 2.6 mass of cold air plus 1.6 times cold air, hot air, should be 2.6 mc, 2.6 से मल्टीप्लाई करना, m1 आएगा 2.6 into mc and that will be equal to 2.6 mc, कितना आ रहा है सर? 1.8685, 1.8685, तो मास आ गया सर, यहाँ पे पुट करना 1.8685 and cp is 1.005 and t2 minus t1, t2 is 28, so अगर ये सेंटीग्रेड में है, ये भी सेंटीग्रेड में 28, and already T1 we have calculated in centigrade 23.6, ये बहुत इंपॉर्टेंट है सर। if this is in centigrade, देखो if this is in centigrade, this should be in centigrade, यहां से आपको हीट ट्रांसफर आएगा, कितना आ रहा है सर हीट ट्रांसफर? no one is following, no one is following, मस्त क्वेश्चन था सर, ये भी मस्त क्वेश्चन था सर। How much is this? अरे यार, what is the answer? ऐसे क्वेश्चंस आएंगे सर. 8.26 kilowatt. Yes, 8.26 is correct. 8.26. If I am calculating, यहाँ आ गया 8.26. ठीक है सर. आज के लिए लास्ट क्वेश्चन करेंगे. लास्ट क्वेश्चन ये करेंगे आज के लिए. तो कल करता हूं सर, अब बंद कर देंगे, ठीक है, बिकॉज मॉर्निंग आई हैव क्लास, माफ करना. सो आई एम स्टॉपिंग द क्लास. अब स्टॉप कर रहे हैं हम, ठीक है सर. सेशन ठीक था, थोड़ा बताइए, काइंडली कमेंट. अब कमेंट्स में करना, अगर अच्छा लगे तो, बुरा लगे तो वो भी कमेंट करना, बुरा लगे तो भी बोल देना, अच्छा लगे तो भी बोल देना. कैसा लगा, ठीक लगा? एंड कल मैं सोच रहा हूं स्पेशल क्लास लेने का. तो बाकी के क्वेश्चंस तो बहुत इंपॉर्टेंट है सर, बहुत अच्छे क्वेश्चंस हैं. कमेंट करना प्लीज, आफ्टर द क्लास कमेंट करो. टुमारो शैल आई टेक जे रेडी? टुमारो एक्चुअली आफ्टरनून आई हैव टू गो. रात में कोशिश करता हूं सर, आई लेट यू नो प्लीज. ओके, थैंक यू, बाय बाय. आई एम एंडिंग द सेशन. गुड बाय, गुड नाइट. बहुत दिन बाद यूट्यूब लिए सर, लाइव सेशन अच्छा हुआ. थैंक यू, गुड बाय. थैंक यू सर, थैंक यू. भरत कुमार, भरत. वंडरफुल सर, थैंक यू. बाय बाय, गुड नाइट. Please don't take in plus sir for questions. Acha, you want on YouTube or special class? Special class will be fine.